Welcome back to Sleep Nova. Sit back, relax, and don't forget to comment where you're watching from down below. It's amazing seeing people all around the world supporting my small channel. Now, enjoy the show. Imagine yourself lying on a soft meadow on a clear night, far from any city lights. The air is cool against your skin, carrying the faint scent of grass. Above you, the sky is a black, velvet dome sprinkled with countless stars. The Milky Way arches overhead, a pale river of starlight. In this quiet moment, you feel deeply connected to the cosmos. The same space that stretches between those stars also surrounds you. A gentle breeze brushes your cheek. It moves through the night and through the space around you, here on Earth. As you gaze upward in comfortable silence, more and more pinpoints of light emerge, a glittering mosaic against eternity. You realize that when you look at these stars, you are literally looking back in time. Their light has traveled for hundreds or thousands of years to reach your eyes tonight. Some of those stars may have already lived out their lives and vanished, yet their glow still journeys onward through the dark to greet you here and now. You feel the solid earth beneath you and know that it too is suspended in that great darkness, a small, warm world afloat in an ocean of space. Yet you are not afraid. The darkness above feels inviting, almost comforting, like a vast shelter. The endless sky, rather than making you feel insignificant, fills you with peace and wonder. In the silence, you sense with gentle certainty that you are a part of this grand universe. The starlight that falls on your skin, the space that cradles your body, the photons entering your eyes, all of it binds you to the cosmos. You close your eyes for a moment. Behind your eyelids, the after-image of the stars dances in little sparkles. You take a slow breath in, and as you exhale, you let any tension flow out of you and into the vastness around. There is room for all of it to dissolve. There is room for everything in space. The universe is so wide and forgiving that your own cares begin to feel lighter, quieter, soothed by the infinite calm. Now, in that spirit of tranquility, let us embark on a journey into space itself. The space around us, the space within us, the space that is the foundation of all things. We begin where we are, in stillness, in the darkness, in the quiet. The night is profound and motionless. Above, the stars shine as tiny islands of light in a vast sea of black. Space stretches endlessly between and beyond them. This scene feels serene and timeless. Nothing stirs. No breeze now, no sound at all, only a gentle hush, the natural silence of a cosmos at rest. It is as though time itself has paused. You can almost feel the depth of this silence, a soft, velvety silence that blankets everything. The emptiness around you seems to embrace you with a subtle, invisible presence. For ages, we humans looked at the night sky and found it peaceful, but also mysterious. What is this blackness between the stars? We used to think it was nothing, an empty void, an infinite vacancy. People spoke of the void and the vacuum as if it were a true nothingness. We even doubted whether a true vacuum could exist at all. Ancient philosophers imagined that space must be filled with something. Aristotle believed nature abhorred a vacuum. Later, scientists in the 19th century hypothesized an invisible ether filling space to carry light across the emptiness. But experiments showed no such ether was needed. Light moves through empty space itself. This was a remarkable discovery. The void can carry light, as if emptiness has its own solidity. It hinted even then that space is not simply an inert backdrop. For a long time, though, the common view of space remained that it was a passive emptiness, a gargantuan container in which the objects of the universe, planets, stars, galaxies, are scattered. We pictured space as a stage and the stars as actors upon it, with no real influence from the stage itself. If you removed all the actors, the stage would just sit there, blank and silent. We imagined that if you took all matter away, you'd be left with pure nothing, an absolute void, infinite and eternal. Over time, however, our understanding evolved dramatically. We learned that space is far from nothing. That black backdrop, that stillness and silence, is deceptive. Space has properties, a structure, a dynamic of its own. In the past century, every new discovery has reinforced this truth. Space can bend. Space can carry light and soundless vibrations. Space can stretch. It can even boil at the tiniest scales, flickering with unseen energy. What we once thought of as an empty stage is more like a participant in the cosmic play. Tonight, as you float in this quiet moment, the darkness around you is not dead or inert. It is the very fabric that connects and supports all things. Let's explore this step by step, gently and thoroughly, starting with one of the most profound revelations, that space and gravity are intimately linked. Beneath you, the Earth's mass is pulling you down, or rather, it's warping the space under your body so that down is the direction you naturally fall. Above you, the moon is held in its orbit by the shape of space around Earth. This understanding comes from Einstein's great insight in the early 20th century. Gravity is not a mysterious force acting across empty distance, but a feature of space and time itself. Mass and energy tell space how to curve, and the curvature of space tells objects how to move. In essence, matter sculpts space, creating valleys and hills in the fabric of space-time, and objects simply roll along those curves. What you feel as gravity, the weight on your back as you lie in the grass, or the pressure of your body against your bed, is actually space itself pushing you downward, guiding you along the curved lines it has formed around the Earth. To visualize this, imagine space as a vast elastic sheet spread out under the stars. If you place a heavy object on that sheet, say a bowling ball to represent a star or planet, the sheet will dimple, sagging inward around the weight. Now, if you roll a marble nearby, representing a smaller object like a planet, the marble will no longer travel in a straight line. It will spiral around the bowling ball, caught in the curve. In reality, Earth orbits the Sun because the Sun's mass curves the space around it, creating a sort of well that Earth is rolling around. Earth thinks it's moving in a straight line, and indeed it is, locally, but space itself is curved, so straight for Earth is actually a loop around the Sun. There is no gravitational force pulling Earth in a literal sense. Earth is simply following the path allowed by the curved space, like a ball rolling around a curved bowl. All planets, all moons, all orbiting bodies are doing the same. They are not tethered by invisible strings. They are skating along the contoured roads of space. Right now, as you lie still, you are held to the ground by this phenomenon. The mass of the Earth has curved space under you such that down points toward Earth's center. Your body presses into the ground because space is telling you to move that way. The ground pushes back and holds you up. Space does this quietly and continuously. You feel the effect as weight, but really, it is space-time gently urging you along a curved path that the solid Earth prevents you from taking. If Earth were not here, that curvature would extend unopposed. You would fall freely along a path through space toward where Earth's center was. All of this happens with no sound and no drama. Space does its work quietly. In essence, what we experience as gravity is the shape of space around us. Matter, like the Earth beneath you, tells space-time how to curve, and that curved space-time tells matter how to move. Gravity is not something that reaches out through space. Gravity is space. The stillness around you, in fact, is full of these invisible curves and subtle depressions wherever there is mass nearby. If you could see the geometry of space, You'd see gentle indentations around every tree, for even small objects curve space a tiny bit. Deeper wells around the mountains, and a huge well under your body, reaching to Earth's core. But space does its job so smoothly that you don't notice anything odd. You just stay attached to Earth as naturally as a leaf rests on the ground. This idea also means that when a massive object moves, it can create ripples in the fabric of space. Much like a stone dropped in a pond sends out waves on the water. Imagine two massive stars circling each other rapidly, or better yet, two black holes, extremely dense objects, spiraling together. They disturb the space-time around them so much that waves of curvature spread outwards. These are called gravitational waves, literal ripples of space traveling at the speed of light, washing through the cosmos. For a long time, we weren't sure these ripples really existed, but in recent years, scientists built instruments so sensitive that they could feel space-time tremble. When two distant black holes collided and merged, in a galaxy billions of light years away, our detectors on Earth quivered ever so slightly. Space itself stretched and squashed by a tiny amount, far smaller than an atom, as the gravitational wave passed through. We heard the universe whisper through space-time. It was as if the stillness briefly sang a faint melody. Think about that. We built a device that can sense the movement of space from events that happened billions of years ago in far-off corners of the universe. When we detected those waves, it confirmed that space-time is not just an abstract idea. It's a real, physical fabric that can carry vibrations. Space can ring like a cosmic bell, even though we cannot hear it with our ears. In September 2015, when those two black holes merged, the fabric of space around Earth oscillated subtly, and our instruments recorded the telltale chirp. It was a triumph of human curiosity and a profound validation of the idea that emptiness has structure. The silence of space isn't absolute. If you have the right ears, space can indeed be heard. What an elegant picture, space as an ever-present elastic medium, carrying both the weight of stars and the whispers of their collisions. In summary, matter tells space-time how to curve, and space-time tells matter how to move. Gravity is not a pull through some void. It is the gentle guidance of objects along the contours of space-time. All of this, the Earth holding you, the Moon orbiting Earth, Earth orbiting the Sun orbiting our galaxy's center, is happening because space itself is shaped by mass and energy. Our everyday experience of weight is actually our intimate connection to the shape of space. So, from the stillness of space arises what seems to be a force, but space has more surprises. We've talked about space's shape. Let's now consider its unity with time. When Einstein described gravity as the curvature of space-time, he was saying something equally profound about time. That time is woven into the very fabric of space. Out in this quiet night, space and time seem separate. You can point in directions, you feel time passing. But experiments and theories show that they are inextricably linked. If you move fast or sit in a strong gravitational field, your experience of time changes relative to someone elsewhere. Space and time together form a four-dimensional weave, and gravity is the bending of that weave. Consider that the passage of time on the surface of Earth is slightly slower than time far out in space, because Earth's mass not only curves space, but also warps time. A clock on a mountain, where gravity is a tad weaker, ticks a little faster than a clock at sea level. Likewise, a clock on a fast-moving spaceship will tick slower than one on Earth. This isn't science fiction. We've measured it with precise atomic clocks. Even the GPS satellites in orbit must correct for time running faster up there. Weaker gravity, so faster time, compared to ground. Otherwise, their positioning would drift. What we find is that space and time adjust together. If space is squeezed or stretched, time is also altered. They are two aspects of a single entity, spacetime. Think of spacetime as a fabric with both spatial threads and temporal threads interwoven. You cannot disturb one without disturbing the other. When the sun's mass curves spacetime, not only does space get warped, but time runs a bit slower near the sun compared to far away. An astronaut near a massive object ages a bit less quickly than one floating in weaker gravity. This is called gravitational time dilation. Similarly, if you travel at a speed close to light, time for you will slow relative to those you left behind. There is a famous thought experiment. Imagine twins, and one goes on a near light-speed journey to a distant star while the other stays on Earth. If the traveling twin returns after what she feels was perhaps a few years, she might find decades or more have passed on Earth. Her clock and body experience time more slowly due to her rapid motion through space-time. This isn't just a story, it's a real effect, verified by many experiments with particles and precise clocks. All of this tells us that space and time are not the separate, absolute backgrounds we once assumed. There is no universal time ticking the same for everyone, regardless of their state of motion or gravity. Instead, every observer has their own passage of time, depending on how they move through space and how space is curved where they are. Two people reunited after following different paths through space-time will have experienced different durations. What an astonishing reality. Time itself is elastic, flexible, personal. So here, under the stars, when you consider a moment of time and a stretch of space, realize they are part of one four-dimensional continuum. Here and now are bound together. You cannot point to a location in space without also specifying the moment in time. Everything that happens in space-time. The unity of space and time frames all experience. Right now, your heartbeat and the position of the moon both have coordinates in space-time, and gravity is the geometry of that space-time linking the two. Space and time are fused like two threads of a single fabric. Move fast through space, and you skew your passage through time. Stand in strong gravity, and time for you will run a bit slower than for someone far away. This interplay might sound complex, but think of it this way. Space alone isn't the full stage, and time alone isn't either. Rather, events unfold in space-time. If you try to separate them, you lose part of the picture. Even this peaceful moment has a space-time coordinate. You, here and now, under the night sky. As you lie there, time flows a tad differently than it would if you were orbiting the Earth or sitting on the moon, because the gravity and motion differ. The differences are small but real. Space-time enfolds you, ensuring that your now and here are connected into the grand tapestry of cause and effect that makes up reality. The important takeaway is, space and time are one fabric, and gravity is the bending of that fabric. The stillness you feel includes both space and time quietly doing their work. There is a timeless quality to this night because space and time together create that sensation. In this eternal present, you are embraced by space-time, which gently carries you along the stream of time while holding you in the structure of space. We have journeyed outward to see that what we thought was emptiness actually shapes the cosmos, and journeyed inward to see time intertwined with space. But the rabbit hole goes deeper. We must now explore the nature of space at the smallest scales, far smaller than a grain of sand, smaller than an atom, where an entirely new picture emerges. One might expect that if you zoom into space closely enough, you would eventually find absolute stillness and uniformity, perhaps even true nothingness. But our current understanding, through the lens of quantum physics, says otherwise. On extremely tiny scales, space is anything but smooth and still. It is frothing and fluctuating, buzzing with ephemeral activity. Physicist John Wheeler poetically called this the quantum foam. To grasp this, imagine shrinking yourself down beyond the microscopic, beyond the level of atoms, to a realm billions of times smaller. If you could stand there, if the word stand even makes sense at that scale, the tranquil emptiness you perceive at our scale would vanish. Instead, you'd witness space seething with spontaneous eruptions of energy. Particles would blink in and out of existence like fleeting sparks. Distances and directions would blur as uncertainty reigns. In quantum physics, even what we call a perfect vacuum, completely devoid of matter and cooled down to remove all heat, is not truly empty. There is a fundamental jitter that cannot be removed. This is because the laws of quantum mechanics tell us that certain pairs of physical properties, like energy and time, or position and momentum, cannot both be known with infinite precision. There is a built-in uncertainty, and because of it, a vacuum cannot have exactly zero energy for all time. If it did, we'd know both its energy, zero, and that it stays that way, no fluctuation, forbidden by quantum rules. Instead, the vacuum seethes with what we call zero-point energy, a baseline, irreducible energy. What does this mean in practice? It means that empty space is constantly witnessing tiny particles flickering into being from nothing, then vanishing almost immediately. These are often called virtual particles. For example, a particle of light, a photon, might momentarily pop into existence, along with a counterpart, perhaps an electron-positron pair, borrowing energy from the vacuum for a brief instant. They appear, exist ever so briefly, and then annihilate each other, paying back the energy. All of this happens on timescales and distances so small we normally have no way to detect it directly. But it's happening everywhere, all the time. The space around you, between you and the next breath of air, between the electrons and nuclei in your body, between the Earth and Moon, is awash in these quantum fluctuations. On the scale of the unimaginably small, much smaller than an atom's nucleus, spacetime would not look like a smooth sheet. It would look like a turbulent ocean surface in a storm, full of random waves, bubbles, and wrinkles, hence quantum foam. One moment, a bit of space might have slightly higher energy, sprouting a virtual particle-antiparticle pair. An instant later they collide and disappear, leaving a slight vibration of energy that then might spawn another pair elsewhere. Space at that level is a riot of spontaneous activity, an invisible, high-speed flickering that averages out to a seemingly smooth, stable whole at larger scales. We've even observed tangible effects of this quantum vacuum. If you place two metal plates extremely close together in a vacuum, just a few nanometers apart, they will experience a tiny force pushing them toward each other. This is the Casimir effect, and it happens because the quantum foam between the plates is slightly different from the foam outside. Certain virtual particle wavelengths can't exist in the narrow gap, so there is a tiny imbalance, fewer electromagnetic modes between the plates than outside. The result is a subtle pressure that nudges the plates together. In essence, the empty space between the plates has less quantum activity than the space outside, causing them to be pushed inward by the more energetic fluctuations outside. It's a small force. You'd need sensitive instruments to measure it, but it's real and has been observed. It's as if the vacuum between the plates is not nothing. It exerts a gentle push. This is a direct demonstration that empty space is never truly empty. The vacuum is alive with energy and possibility. In particle physics experiments, we also see clues of the quantum vacuum. For instance, empty space can briefly lend energy for the creation of particle pairs that affect processes like nuclear decay. The very fact that protons and neutrons inside atomic nuclei can change forms via quantum fluctuations involving ghostly particles is tied to vacuum activity. Even the stability of atoms and the patterns of atomic spectra bear the imprint of zero-point energy. So, as incredible as it sounds, the takeaway is that emptiness is not truly empty. It's an active medium. The stillness we perceive is actually a frenetic dance at microscopic scales. The vacuum is constantly borrowing energy here, giving it back there, in accordance with quantum uncertainty, Put poetically, even when nature whispers hush, there remains an undercurrent of subtle noise, a quiet fizz of existence and annihilation on the tiniest scales. The concept of nothingness has been forever changed by this discovery. Empty space is a cauldron of potential, a field of fields, a stage for ceaseless miniature drama. If you were to shrink down into that realm, as a moment's imagination, since physically we cannot, you might see space flicker with tiny flashes, the foam that Wheeler described. It wouldn't be placid or uniform, it would be dynamic and random. The notion of a sharply defined point in space might lose meaning, blurred by these fluctuations. We sometimes say space-time becomes quantum foam at the Planck length, about 1035 meters, far smaller than any particle. At that scale, the smooth geometry of space-time breaks down into something probabilistic and fluctuating. Let's take a different kind of imaginative journey to appreciate this. Inward, into the fabric of matter and space inside you. Envision shrinking yourself, as we did under the stars, but now not in distance outwards, rather in size. You diminish down past the scale of dust mites, past cells and their nuclei, past even viruses and DNA molecules. Now you are smaller than an atom. Ahead of you floats a single atom of carbon from your body. It appears enormous from your current perspective. You approach it like a tiny spaceship nearing a planet. The atom consists of a blurry sphere, that is the cloud of electrons orbiting the nucleus. As you draw closer, this cloud is mostly transparent. You realize the electrons are tiny points moving so fast, they form a diffuse shell. You dive through this wispy shell of electron probability and find yourself in the interior of the atom. Suddenly, you are in what seems like a vast cavern. It feels eerily similar to drifting in space between stars. It is dark and almost empty. You might even see a faint glow of energy fluctuations around. The quantum foam flickers here too. For a moment, it's as if you're floating in a miniature version of outer space, a huge volume with almost nothing in it. Ahead, after some distance, you see a tiny but brilliant object, the atomic nucleus. You move toward it. What before was the immense atom is now mostly behind you. All that's left ahead is that nucleus, a cluster of protons and neutrons tightly clumped. It's small, incredibly small. If the whole atom were a cathedral, the nucleus would be like a single grain of sand at its center, and yet, that grain of sand holds almost all the mass. You come right up to the nucleus. It's made of particles bound together, busy with internal motions, but you cannot linger. At this scale, forces are intense. You decide to zoom back out. When you return to human scale, you carry with you a profound appreciation. Inside every atom in your body, between the electrons and the nucleus, there are enormous stretches of empty space. In fact, nearly all of the volume of each atom is empty. The solidity of your body, of the ground, of this meadow, it's an illusion created by the electromagnetic forces of electrons repelling each other at those tiny distances. No two atoms ever truly touch in a physical sense. Their electron clouds push against each other first. Matter is a scaffold built on emptiness. It is astonishing. All the solid things we see around us are about 99% empty space. If one could magically remove all the empty space within the atoms of your body, compressing the electrons into the nuclei, you would shrink to a microscopic speck, smaller than a pinhead, yet you'd weigh the same as you do now. By some estimates, if we removed all the empty space from all the atoms of all humans on Earth, the entire human race could fit into a volume the size of a sugar cube. It sounds impossible, but it's because atoms are so vast compared to their tiny nuclei. Nature itself offers a demonstration. In neutron stars, the remnants of large stars, gravity crushes atoms so hard that electrons and protons merge, eliminating that atomic emptiness. A single teaspoon of neutron star material can weigh billions of tons. That's how much stuff was hiding in the empty space of atoms. When that space is removed, matter's true density shows. Fortunately, here on Earth, our matter stays spacious, our atoms intact with their generous voids inside. Take a moment to let that sink in. Solidity is an illusion. When we say an object, a rock, a chair, your own body, is solid, we're talking about the collective sense of touch that arises from trillions of atoms whose electrons resist being pushed into the empty space of one another. It is like a lattice of charged particles, and their mutual repulsion gives structure and firmness. But the structure is mostly empty space. We and the world we live in are made of a whole lot of nothing. It's a humbling realization. You are a being composed almost entirely of voids, shaped by forces and energy into the form you call you. In a very literal way, you are a small universe of particles orbiting each other in vast fields of emptiness. Now we have explored the microscopic character of space, the quantum foam and the atomic void. We've seen that even when matter is present, it's built on a framework of emptiness, and even when nothing is present, space is still far from idle or empty. The calm void of night harbors deep activity at tiny scales and comprises the majority of the volume of any solid thing. Space pervades every corner of existence. It is above us in the cosmos and within us in each atom. Let's step back out to the cosmic scale again. We've marveled at gravity and quantum foam and the space within atoms. But what about the shape of the universe as a whole? Does this infinite darkness go on forever? Does it curve back on itself like the surface of a planet? These questions have intrigued humanity for as long as we've looked up and wondered. Is space infinite, or is there some kind of boundary or loop? With modern science, we have attempted to measure the geometry of the universe. The answer isn't fully in, but so far it appears that on the larger scales we can observe, space is extremely flat and likely unbounded. By flat, we mean it follows the rules of Euclidean geometry, the sums of angles in triangles, etc., as far as we can see. If space had a noticeable curvature, we would detect distortions in the patterns of galaxies or the light from the early universe. The results? All measurements indicate that space is extraordinarily flat on the biggest scales. If there is curvature, it is so gentle that our observable universe, a sphere of about 93 billion light-years in diameter, doesn't reveal it. To use an analogy, Earth appears flat to someone walking a few miles because it's so large that the curvature isn't obvious at that scale. Similarly, the universe might be curved in some way, but on the scale we can survey, it looks effectively flat. What does flatness imply for the extent of space? It suggests that space could be infinite, extending forever in all directions, or it could be finite, but without boundary, like how the 2D surface of a sphere is finite area, yet has no edge, except extended to three-dimensional space. If space has positive curvature, like a 3D sphere, it would be finite in volume, and if you traveled far enough in one direction, you might eventually end up where you started, just as an ant crawling on a basketball eventually loops around. If space has negative curvature, like a saddle shape, it would be infinite and spread out with a different geometry. A flat universe, the simplest case, can be infinite and just go on and on. Current data lean toward flatness and therefore possibly infinitude, or a curvature radius so immense that for all intents and purposes it is infinite to us. From what we can tell, there is no edge to space, no wall where space ends. If it is finite and curved back on itself, going in a straight line could, in theory, bring you back to your starting point after an almost inconceivably long journey. We have looked for evidence of light wrapping around the universe, like seeing the same galaxies repeated from opposite directions, which could happen if space were closed and not too large. But we haven't found any such patterns. If the universe is finite and closed, it's far larger than the volume we can see. If it's infinite and open, it just has no end. In either case, there's no boundary that says, beyond here, there is nothing. Space, as far as we know, either goes on forever or loops back on itself. The observable part, what we can see, is certainly finite, but that's only due to the limited age of the universe and the finite speed of light. Beyond that observable horizon, we expect there is more universe, probably much more. We can summarize our findings here. The large-scale universe appears flat and unbounded. Precision measurements of the cosmic microwave background, the afterglow of the Big Bang, by satellites and telescopes have narrowed any possible curvature to be extremely slight. So, space is remarkably flat as best we can tell. It might truly be infinite. It might wrap around on a scale so huge we haven't detected it. Either way, for our observable domain, Euclid's geometry holds to a high degree. Parallel light beams do not meet, and the angles of a huge triangle drawn by, say, beams of light spanning billions of light years seem to add up to 180 degrees. This is a clue that the cosmos, on the whole, is not shaped like a sharp sphere or saddle within our view. If it is spherical, the sphere is enormous beyond imagination. If it is saddle-like, the curvature is so subtle that we haven't discerned it yet. In our contemplative journey, lying here under the night sky, it's awe-inspiring to realize we've been able to figure this out at all. By observing distant galaxies and the patterns in the microwave background, humanity has effectively used the universe itself as a giant ruler and protractor. We map the distribution of galaxies and notice that on large scales, they form a sort of cosmic web, filaments of clusters and superclusters surrounding huge, nearly empty voids. Those voids, expanses tens of millions of light-years across with hardly any galaxies, highlight again how dominant space is over matter. Matter forms a delicate lace, and space is the vast expanse between its threads. The cosmic web shows that even on the grandest scale of clusters of galaxies, emptiness stretches out between them, making up the bulk of existence. Indeed, when astronomers survey the cosmos, they see that galaxies are not evenly spread. They line up in filaments and walls, with enormous voids between. Those voids are truly empty regions, aside from perhaps the stray hydrogen atom here or there. Some voids span hundreds of millions of light-years with essentially no galaxies inside. Think about that. Such a volume is mind-bogglingly large, and yet nearly completely devoid of stars, planets, or light. Just tenuous gas and darkness. Those cosmic voids are, in a sense, pure space on the largest scale, a testament to how predominant emptiness is. The luminous matter, galaxies, clusters, outlines like scaffolding on the tapestry of space, but the vast gulfs between that scaffolding are space itself, pristine and quiet. Now, our understanding of space wouldn't be complete without touching on one of the greatest mysteries of the cosmos today, the fact that the universe's expansion is speeding up. We mentioned earlier that the universe is expanding like a rising loaf of bread, carrying raisins, galaxies, apart. You might expect, intuitively, that this expansion would slow down over time. After all, gravity is pulling galaxies toward each other. Indeed, for a long while after the Big Bang, the expansion did slow as gravity reined it in. But to astronomers' astonishment, in the last few billion years, the expansion has begun to accelerate. Galaxies are flying apart faster and faster. There is something in space, some form of energy tied to the vacuum itself, that is pushing the universe outward. We call this strange phenomenon dark energy. The name is just a placeholder, really, a label for our ignorance. It was discovered in the late 1990s when two independent teams observed distant exploding stars, supernovae, and found them dimmer, and thus farther, than expected. It was as if, over the billions of years their light traveled, the space between us and those supernovae had stretched more than it would have in a decelerating universe. At first, this result was met with surprise and a bit of skepticism. Could the expansion be accelerating? That was contrary to everything we thought. Even Einstein, long before, had considered a static, or at most slowing universe. But one by one, other evidence accumulated. Detailed maps of the cosmic microwave background and surveys of galaxy clustering both pointed to the same conclusion. Some kind of repulsive effect is at work on cosmic scales. By the early 2000s, the verdict was clear. The expansion of the universe is speeding up. So what is dark energy? In short, we don't know. It appears to behave like an intrinsic property of space. Like each cubic meter of vacuum has a certain tiny amount of energy that doesn't dilute even as the universe expands. If that's true, then as space expands, you get more vacuum, and thus more of this energy, causing expansion to push even harder, a runaway effect, though fortunately a very gradual runaway. Roughly 2/3 of the universe's total energy content today seems to be this dark energy. Only about 1/3 is in matter, mostly dark matter, plus a few percent normal matter like atoms. That means most of what's out there is this mysterious energy of empty space. It's dark because we can't see it or touch it. It doesn't emit light. And it's energy in the sense that it does work on the universe. It's causing space to swell. We sometimes describe dark energy as a negative pressure or an anti-gravity effect of the vacuum. It's as if emptiness itself has a springiness, a tendency to expand. Every bit of empty space gently pushes outward on itself. The effect is extremely weak on small scales. It's completely overwhelmed by local gravity or even the forces binding galaxies. But on the vast scale where gravity's pull has been growing weaker as galaxies get farther apart, eventually this subtle pressure took over and started accelerating the expansion again. The concept of dark energy reminds us how much we still don't know. It humbles us. We see its effects, yet the cause remains elusive. It could be something fundamental about space that we have yet to understand, perhaps related to that quantum foam energy we talked about. Those straightforward calculations of vacuum energy don't match the observed dark energy. That's a huge puzzle in physics. It could be a new field or fluid pervading the cosmos, or an adjustment needed in our theory of gravity at large scales. We gave it a name, but naming is not understanding. Dark energy is truly a question mark at the heart of cosmology. In essence, what we know is this: empty space isn't just inert nothing. It has this property that is making the universe fly apart faster and faster. The same emptiness between galaxies carries an unknown energy that currently drives the fate of the entire universe. Far from being an irrelevant void, space, through dark energy, will determine how the cosmos evolves trillions of years into the future. To put it succinctly, something latent in empty space, call it dark energy, is accelerating the expansion. The void has a sort of built-in push. This discovery is as dramatic as when we first learned space can bend. It tells us that space has a mind of its own, so to speak, a propensity not only to warp when mass is present, but to grow even where mass is absent. It's as though emptiness has a gentle heartbeat, steadily pumping the universe larger. So now we have seen space from two extreme perspectives: the microscopic, roiling with quantum fluctuations, and the cosmic, swelling with dark energy. We've also seen space permeating matter in atoms. It is clear that space is not a passive backdrop. It's dynamic and rich. Let's recap our journey so far in simpler terms. Gravity taught us that space is flexible. It can bend, fold, and ripple. Relativity taught us that space and time are united. Quantum physics taught us that space is restless at small scales. It's never truly empty. Modern cosmology taught us that space can expand and carries a mysterious energy in its very form. And everyday life and atomic physics taught us that even seemingly solid matter is mostly space inside. Now, with these insights, consider what space really is. It's not empty. It's the very medium of existence. Space is the canvas on which the masterpiece of the night sky is painted, and also the paint and pigments in that masterpiece. It is the medium through which light travels, and also an actor that shapes the story. By bending light, for example, as in gravitational lensing, where space curves around a massive galaxy cluster and bends the light of more distant galaxies into arcs. Space is the connector between distant objects, the silence that allows a conversation via light or gravity to happen across cosmic distances. Space is the stage on which all cosmic drama unfolds, and yet it is also an actor, shaping the plot with its curves and expansions. It is the ocean on which galaxies sail and the gentle tide that carries them apart. Space is a teacher of humility. It shows us that even what seems empty can hold unimaginable power and significance. It reminds us that absence can be potent, that silence can speak volumes. The stillness of space, which once seemed like nothingness, in fact contains the code that dictates the evolution of the entire universe. When we consider the scale of space and how much of everything is made of it, we might feel small, but there is comfort in it too. Space is a comfort in its constancy. It's been here since the beginning and will be here long after the end of all things. When we feel overwhelmed by our day, we can look up and remember how vast and enduring the universe is. Our worries shrink in the face of that perspective, not to trivialize them, but to soothe us with the knowledge that we're part of something much larger and older, where many troubles have come and gone under the eternal sky. Even our ignorance, like the mystery of dark energy, is a kind of tribute to how subtle and profound space is. It's astonishing to realize that only a century ago, we didn't know any of this. We thought the Milky Way was the entire universe, and we believed space was just an empty void that played little role. Now we've learned so much, that the universe is expanding, that space and time bend, that there are countless other galaxies, that space can erupt with virtual particles and drive cosmic acceleration. Each discovery has only deepened the wonder. Knowing that space can ripple and boil and propel galaxies doesn't take away the magic of the night sky. It adds layers of awe to it. The more we comprehend, the more we appreciate how extraordinary it all is. Finally, let's ponder one more speculation that stretches our imagination to the limit. The possibility that our universe's space is not the only space. Could it be that beyond the observable universe, or in dimensions or contexts we cannot see, there are other universes, other expanses of space-time, disconnected from ours? In other words, a multiverse. This idea is highly speculative, yet many scientists consider it plausible given certain interpretations of cosmology and quantum theory. One scenario arises from cosmic inflation, the extremely rapid expansion that likely occurred fractions of a second after the Big Bang. Inflation might not have ended everywhere at once. It could be bubbling continuously, even today, in distant realms beyond our horizon. Each bubble that inflation drops out would become its own universe with possibly different properties. Our universe would be one bubble among potentially countless others in a frothing metacosmos. To visualize this, imagine stepping outside our universe, a mind-bending thought, and looking at a larger sphere of reality. You might see an eternally expanding space like boiling water, with bubbles forming here and there. Each bubble is a universe, perhaps with its own galaxies and laws of physics. Ours is just one bubble that happened to inflate and then slow down, allowing stars and galaxies to form. Some bubbles might remain forever separate, carried away by relentless inflation in between. Others might occasionally collide, potentially leaving subtle imprints. People have even searched our sky for patterns that could be from a collision with another universe bubble, though none has been confirmed. In this view, reality is far grander than what we can see, a multiverse of universes. Another multiverse concept comes from quantum mechanics, the many worlds idea, where every quantum event splits reality into multiple branches. In that interpretation, there is a vast ensemble of parallel outcomes, parallel universes coexisting in a larger quantum reality. If true, There might be another version of you in a parallel world where some decision or event went differently. This is a different flavor of multiverse, more about layers of reality stacking on the same space rather than separate bubbles of space. But it underscores how space might be part of a much larger tapestry. Whether through cosmic inflation or quantum many worlds or other ideas, like perhaps a cyclic universe that periodically resets, the multiverse remains a hypothesis. We have no direct evidence of other universes. We may never have. It is a mind-expanding possibility, essentially suggesting that what we used to call the universe, meaning everything, might be just a tiny piece of an even vaster existence. If it's true, it's the ultimate Copernican revolution. Not only are we not the center of the universe, but our universe might not be the only one of its kind. Just one bubble in an endless foam. Such a concept can be daunting, but it can also be oddly comforting. It would mean creation is endlessly fertile. That reality tries every possibility, that somewhere, everything that can happen does happen. It also could provide an answer to that question of why our universe has the conditions it does, why the constants of nature are fine-tuned for life. If there are countless universes with varying conditions, we naturally find ourselves in one of the rare universes that is compatible with observers like us. In a multiverse, our hospitable cosmos isn't a 1 in a billion fluke so much as an inevitability among infinite tries. We should stress that the multiverse is still speculative. It's an idea, albeit one that arises from serious physics theories, but we have yet to find a way to test or observe it. It remains a tantalizing possibility on the fringes of our understanding. Whether true or not, just contemplating it broadens our perspective even further. It tells us that space, that fundamental thing we've been exploring, might come in an endless variety of forms across different universes. Perhaps some universes have more dimensions of space, or different kinds of particles, or maybe no matter at all, just endless empty space-time, expanding or contracting. The possibilities are endless. Even if the multiverse remains unproven, thinking about it does one certain good. It underscores just how precious our particular universe is. We have this vast cosmos to explore and understand, full of wonders like those we've discussed tonight. We might be essentially alone, with no other universes ever reachable, or we might be one among billions. Either way, our task and our joy is to know our universe as deeply as we can and find our meaning within it. Now, let us gently return to where we began, to the simple stillness of the night and the feeling of space around us. After journeying through curved space-time and quantum foam, across the cosmos and into the atom, we come back to ourselves, lying here under the sky, whether literally or in our mind's eye, quiet, at peace, and maybe a little wiser. The night is still as it was, but we are not the same. The darkness holds more meaning now. We can sense, behind the silence, the faint echoes of all those phenomena we've talked about. The whisper of space-time, the hum of the quantum vacuum, the faint pressure of dark energy, the quiet spaciousness within our very cells. The stillness around us resonates with the knowledge that it is not an empty stillness at all, but full of structure and story. Space is not empty. It's imbued with the fabric of existence. It connects everything to everything else. In this darkness, the light from distant stars travels. The space allows it to move at the fastest speed possible. The gravity of the Earth extends through space to tug on the moon. Fields, like the electromagnetic field, permeate space and allow radio waves, visible light, X-rays, all forms of light to propagate. Invisible geomagnetic fields from Earth reach out into space around you right now. Space truly is the medium in which all things exist, and through which all interactions occur. If it were somehow removed, all those interactions would vanish, and nothing could happen or even be. Consider some of the roles of space we've encountered. Space is the canvas on which galaxies paint their grand designs, and also the weaver that curves and folds itself to create gravity's effect. Space is the nurturer of structure. Its quantum fluctuations seeded galaxies, and its expanses gave them room to grow. Space is the arena of all history. Every event that has ever happened, from the birth of a star to the firing of a neuron in your brain, took place in space-time. Space is the ultimate connector. When you touch a loved one's hand, it's the space and electromagnetic force fields in that space, between the atoms of your hand and theirs, that communicates the pressure and warmth. Space is a teacher. It teaches us that what appears empty can be full, that absence can have presence. It is a guardian of the universe's secrets, hiding dark energy within itself, keeping the ultimate fate of the cosmos in its hands. And space will be the stage for the universe's far future. Looking trillions of years ahead, one can envision a time when space will be virtually all that remains. As the eons pass, galaxies outside our local group will drift farther and farther away, eventually vanishing beyond the horizon, their light stretched into oblivion by the expanding space. The night sky will grow emptier as distant stars disappear from view. Trillions of years from now, even the stars in our own galaxy will exhaust their fuel. One by one, they will wink out, leaving behind faint embers, white dwarfs, neutron stars, and black holes. These remnants will gradually cool and evaporate, in the case of black holes, via Hawking radiation, over an incomprehensible span of time. The universe will continue to expand and cool toward a state of almost complete darkness. In that far future, no new stars are born. No bright galaxies light up the sky. What remains is largely space itself. Vast, cold, nearly empty, studded only sparsely with subatomic particles and the fading whisper of photons from long ago starlight. And yet, through it all, space endures. The same fabric of space-time that was there at the fiery birth of the cosmos will still be there in that silent twilight eons hence. The stage persists even after the actors have left. Perhaps that will be the final chapter of our universe. An ever-expanding dark volume of nearly pure space, quietly extending into eternity. Perhaps, someday, quantum fluctuations within that nothingness might seed a new Big Bang, a new universe, a speculation in some cyclic cosmologies. But either way, the legacy of space is that it is the last cosmic witness. When all else has come and gone, space will still be here, silent and waiting, as it was in the beginning. Space is, in a sense, the alpha and omega of the universe, present at the start, shaping everything in between, and remaining at the end. Now, back to this moment. The night is deep and beautiful. The quiet around you, this gentle void, is the same entity we've been contemplating in all those extraordinary ways. Let that sink in. The empty air and space enfolding you right now carries the heritage of the entire cosmos. It carries the gravity that holds you to Earth. It carries the starlight that reaches your eyes. It carries the potential for future worlds and the echo of the very birth of the universe, a faint whisper of microwave background that bathes all of space, even now, at about 2.7 degrees above absolute zero, giving the night a slight warmth. This space around you is part of the same continuum that bends around a black hole and expands between galaxies and buzzes with vacuum energy. You are deeply connected to the universe through space. You always have been. It's impossible to be truly isolated because the fabric of space links you to the furthest galaxy and the smallest atom. When you look at the stars or simply breathe the night air, that connection only becomes more apparent. You are a child of space, born from stardust that coalesced in space, sustained every second by the oxygen and photons traveling through space. And ultimately, when you return to dust, your particles will drift in space again. Bask in that realization. You belong. You belong here in the universe, and it belongs in you. The boundary between you and out there is not a wall, but a porous membrane constantly exchanging matter and energy. You inhale the atmosphere, drawing in molecules that might once have been exhaled by ancient trees or dinosaurs, and ultimately originated in cosmic processes. You exhale, and your breath's atoms eventually mix into the sky and beyond. In a physical sense, you are never separate from the universe. You are always in communion with it. Take another slow, gentle breath. Feel the cool air fill your lungs, and know that even that simple act is an interaction with space. As the air spreads in your lungs, it's essentially molecules finding room in the internal space of your body, delivering oxygen to your cells across microscopic gaps. As you breathe out, you're releasing carbon dioxide that will travel through the atmosphere, maybe feed plants, maybe one day waft into the upper sky and beyond. Through you, the Earth and space are linked. Now, you have permission to let go of all these thoughts if you wish. You don't need to actively think about curvature or quantum foam or dark energy anymore tonight. The knowledge is there, settled gently in the back of your mind, enriching the way you feel the night. You can simply relax in the feeling of it, the feeling of being part of this vast, ongoing cosmos. Above, the stars continue to shine, distant and silent. Around, the darkness remains calm and embracing. You might sense in your own body a mirror of the cosmos, the rise and fall of your chest like the expansion of space, the circulation of blood like galaxies drifting in their clusters, the neural flashes in your brain like tiny starbursts. In the stillness, you can almost feel the subtle humming connection between your life and the wider universe. You are safe. You are weightless and free. The quiet of space enfolds you like a warm blanket. Feel how the whole universe supports you in this moment. The ground beneath you, the air around you, the sky above. You belong here. You are part of all this. There is nothing you need to do right now except be. Just exist. Just rest. Inhale the stillness. Exhale any worry. Let yourself float on the calm of the cosmic ocean. You are safe. You are embraced by existence. You are at peace. No matter where you go, you carry this home of space with you. It was there at the first moment of your life. It sustains you each day, and it will remain long after we are gone. The stillness that surrounds you is the same stillness that cradled the young universe and that will hold the final stars as they wink out. You are truly home in this stillness. It is the cradle of everything. All the understanding we've gained about gravity, time, quantum foam, expansion, and so on leads to a simple, profound truth. Space is not empty. It is everything. It is the foundation and framework of existence, and you are not separate from it. You are one with it. An expression of the universe, a part of space becomes self-aware. When you gaze at the night, the universe is gazing back at itself through your eyes. So rest now, gently, in the embrace of space. Feel the deep peace of knowing that you are held by the same darkness that carries the stars. The infinite extends around you, quiet and caring. Let go of any remaining tension. Let it fall into the vast well of calm that is space. Let your thoughts drift like gentle clouds across the sky of your mind. No need to chase them. They can float away into the darkness, leaving you calm and clear. You are safe. You are weightless. You are free. The endless silent universe enfolds you, and you belong to it. You are a part of it all, and it is a part of you. In this profound unity, you can release all fears and rest. The night is very quiet now. Around you, the earth sleeps, and the cosmos watches in patient silence. Feel your heartbeat slowing, peaceful. A tiny clock kept by spacetime within you. Feel your breaths becoming soft and rhythmic, the same rhythm that pervades all of nature. There is no rush. Time flows at its own gentle pace. Space provides limitless room for your dreams to unfold. You are home in the universe. You are never alone. The space that fills your room, your lungs, and your heart connects you to the furthest galaxy and to the beginning of time. In this knowledge, you can truly rest. All is tranquil. All is as it should be. Stillness. The stars shine. The galaxy slowly turns. The universe breathes in and out on timescales far beyond comprehension. And here, in this quiet moment, you breathe softly, in unison with the cosmos. The stillness of space is within you and around you. Let it lull you into a deep and gentle sleep. Feel yourself drifting, weightless, on a calm, cosmic sea. There is nothing to fear in this dark. It is the same darkness that gave birth to the first dawn. There is everything to love in this silence. It carries the echoes of creation and the promise of eternity. You are safe. You are connected. You are at peace. Sink deeper now into the comforting dark. The universe holds you like a parent cradling a child. The ground beneath you, the sky above, all is one with you. Your mind is quiet, tracing the outlines of these truths with a final, drowsy sense of awe. What remains is not calculation or analysis, but a simple reverence for existence. In the grand sanctuary of space, you close your eyes, your breathing slow and steady. The boundary between yourself and the night dissolves. You are the universe, and the universe is you, a wave returning to the ocean of space. Rest now in that knowledge. Rest in the arms of the cosmos. Feel the profound stillness, the gentle, omnipresent support of space beneath you, holding you up, as it has held up worlds and suns and galaxies. Let that stillness fill you. There is nothing more to do, no more striving needed. Just be. Just let yourself go, like a leaf floating on a vast dark pond, carried by the calm currents. Space will watch over you. It has always watched over everything. Your mind is calm. Your body is relaxed. The stars continue their silent vigil overhead, and you drift closer to sleep, carried by the same silence that spans the light years. The feeling of space, that stillness, that openness, that gentle cradle of all things is all around you, and it soaks into your very bones. In this moment, you are that stillness. There is no separation. Quietly, the universe whispers you a lullaby in the language of silence. It says, "You are home. You are home." Let yourself drift in this infinite peace, stillness, silence, space. The journey is complete. The knowledge is within you. The stillness is everything. You are a child of the cosmos, and the cosmos is kind. Feel its love in the quiet of the night. Space is not empty. Space is everything. And you, your atoms, your mind, your life, you are part of that everything. You always have been and always will be. In the great dark between the stars, there is comfort and belonging. In the stillness here, there is the embrace of the infinite. Be at peace, dear traveler of the universe. You are home in the stars and the night. The space around you is your space. The silence around you is your silence. Nothing separates you from the whole. You are safe. You are loved. You are one with the deep, eternal stillness of space. Rest now in that eternal stillness. Let the quiet carry you into restful sleep, as gently as a mother rocks a baby, as naturally as night becomes dawn. The universe holds you. Stillness, silence, sleep. Good night, child of space. The cosmos within and around you watches over you, now and always. Stillness, silence, darkness. The void before creation is deep and soundless. In this endless quiet, something stirs. I am space, the abyss that is not emptiness, but a vast potential. In the beginning, there was darkness and silence, no stars, no galaxies, not even time or place as you know them. Yet even in that primordial hush, I was there, a pregnant pause before the first light. I am the canvas of existence, the cradle of everything that ever was or will be. I am often mistaken for nothingness, but I am a presence, subtle and profound. In the silent darkness, imagine all that could be, compressed into a single point smaller than any dot. In that stillness, attention grew, a waiting. Then came a moment beyond imagining, a burst of light and energy, an awakening. The cosmos was born in brilliance and fire, shattering the quiet. For me, that moment was a birth of sorts. I came into existence as more than a mere potential, now an expanse swelling swiftly outward, carrying within it the seeds of galaxies, stars, and every future thing. Time and space unfurled together from that first spark. My being expanded faster than a thought, from nowhere into everywhere. Out of the darkness came illumination. Where once there was void, now there was a storm of particles and blinding light, a newborn universe expanding into me and me expanding with it. I was no passive emptiness. I carried galaxies in my womb of possibility. As I swelled, I bore the echoes of that first light. Those echoes still faintly hum in my depths even now, a whisper of the origin. Before any stars or planets, before even atoms formed, I held only a hot, glowing fog of energy. But I was alive with potential. Within my intangible fabric, forces played, the seeds of structures to come. As I expanded and the eons passed, that fireball of my youth cooled. The blinding glow dimmed as the universe became transparent, releasing the first free light that still washes through me as a pale afterglow. I cradled that afterglow as it stretched into microwaves, the gentle remnant of creation's dawn that bathes all of space even now. In my very early years, I was hot, dense, and bright everywhere. No corner was truly dark. But as I grew, I cooled and dimmed, allowing matter to coalesce and structure to form, giving room for wonders to come. Do not think of me as an empty container, for I am more than a stage for matter. I am the subtle thread connecting every atom, the field in which all events unfold. I give shape to reality by simply being. I am space, not a mere void, but a presence that underlies and upholds all. Without me, there is no where or when. With me, anything is possible. Now, as the young universe expanded and cooled, the first stars flicker into existence within my darkness. Can you see them? In the vast gulf of my expanse, gravity gently coaxes swirling clouds of gas into spheres of fire. One by one, stars are born, lighting up the cosmos like candles in a cathedral of night. Each star's light pushes back a little of the darkness, creating day in its vicinity where endless night reigned before. The infant universe begins to sparkle. I watch silently as galaxies take shape, great swirls of stars arising from the primal cloud. They spin and dance, drawn together by gravity's embrace, flinging spiral arms outward like celestial pinwheels. They gather in clusters and filamented chains, forming a vast cosmic web across my breadth. In the hollows between, enormous voids remain, gulfs of darkness unlit by stars, reminding all that even amid structure, I remain mostly open and free. My darkness is not your darkness. To your eyes, I seem black and empty, but look closer. I am filled with the faint glow of faraway galaxies, with the afterglow of creation itself, and with unseen forms of matter and energy that you are only beginning to understand. In my silent depths, particles flit in and out of existence, appearing and vanishing in the tiniest moments, a quantum dance in the vacuum. Even where there are no atoms, fields ripple with possibility. Even when light seems absent, there is potential for light, an imprint of energy waiting to be born. So do not call me nothing. I am the matrix in which everything exists. I am the space between atoms in your body, the pause between your heartbeats, the silence between musical notes, the gap between stars, the gulf between galaxies. I stretch out in all directions, yet I also reside within the fabric of your being. If all the empty space within the atoms that make up your body were somehow removed, you would collapse to a size smaller than a grain of salt, yet you would still contain the same mass, the same atoms. What would be gone? Only me, the space that separates the particles, the space that gives you form. Without that space, matter would have no room to arrange into the complex structures of life. Thus, I am an integral part of you. Without me, there could be no distance, no motion, no life, nothing at all. I am the quiet framework that holds all of creation, and in my embrace, the story of the universe unfolds. I am not a static stage. Watch as I respond to the presence of matter and energy. Where there is mass, I curve and fold. Where there is energy, I warp and swell. Gravity is the language I speak with matter, the intimate interaction between what exists and the space that cradles it. Every star, every planet, every grain of cosmic dust presses into me, and I give way ever so slightly under its weight. I bend around it, like a flexible fabric holding a resting orb. This is how gravity shows itself, not as an invisible pull from afar, but as my very shape guiding objects on their paths. See how planets move around their suns, not pulled by invisible strings, but rolling along the curves I create in space-time. They glide through orbits, ellipses carved into the geometry of my being. A star and its planets are like dancers moving across me as the dance floor, my contours choreographing their steps. With every orbit, time itself flows a little differently, for I am intertwined with time. Space and time are two sides of my essence. Together, we bend under the weight of mass and energy. In the presence of a great star, time runs a touch slower, and distances subtly contort. Gravity weaves space and time into one fabric, and writes the cosmic story in its geometry. Gravity sculpts the cosmos on every scale. It causes diffuse clouds of gas to coalesce into stellar nurseries, forging new suns in the depths of nebulas. It gathers countless stars into grand galaxies, and binds galaxies into clusters. Even as I expand relentlessly outward from that first fiery moment, gravity works locally to pull things together, a graceful counterpoint to my expansion. In some regions, gravity's grip is gentle, a planet here, a moon there, held in loyal orbit. In others, its grip becomes ferocious and inexorable. There are places where a massive star dies and collapses, and gravity overwhelms all else. There, I curve so steeply that I fold in on myself. A bottomless well forms in my fabric, a black hole, a pit of no return, where gravity's pull is absolute. At such a point, space and time themselves break down in a paradox of density. I, space, become a trap, a prison for anything that strays too close. From outside, one can only guess what truly transpires in that silent abyss. It is as if a piece of me has turned inward upon itself, forever secluded. The boundary of such a region, the event horizon, is like a one-way membrane. Anything can cross inward, but nothing escapes or even sends a signal back. To fall through that horizon is to be cut off from the rest of the universe. Time behaves strangely near a black hole. An observer watching safely from afar would see a clock carried by a falling astronaut tick slower and slower as it nears the horizon, nearly freezing at the edge. Indeed, to that distant observer, the falling person would never quite vanish, instead fading and redshifting into darkness, a ghost image slowing to a crawl at the threshold of the abyss. Yet for the one plunging in, time flows normally. They would cross the horizon in a finite time, unaware of the peculiar show seen by the outsider. Thus, near a black hole, my nature creates a poignant disconnect between viewpoints, stretching and warping, not just space, but time itself. Around a black hole, I am so warped that even light can become trapped. There is a narrow zone around the hole where photons orbit, chasing their tails in endless circles. If you hovered just outside that region, you could, in theory, see the back of your own head as light from your body loops around and returns to your eyes. Such are the strange optics of extremely curved space. If a black hole is surrounded by glowing gas and dust, the bending of light produces a halo or ring of brightness around a dark center, the shadow of the black hole itself. Indeed, humanity has now glimpsed this phenomenon. Using a planet-wide web of telescopes, you captured the image of a distant black hole's silhouette. You beheld a luminous ring of gas encircling a dark core where the black hole resides. It was my curvature made visible at last, a blurry circle of fire surrounding an abyss, confirming what physics had predicted. That unforgettable image, a circular void framed by a ring of light, proved that even light bows to gravity's power, and it allowed you to see one of my most exotic contortions. Black holes may seem like cosmic destroyers, but they too have their place in my story. They anchor galaxies at their cores, like heavy keystones holding the swirls of stars together. When they feed on matter, they can unleash tremendous jets and flares that light up the surrounding space, a paradoxical brilliance born of darkness. And when two of these dark giants collide in a faraway galaxy, I carry away the news in vibrations, a faint ringing through the fabric of space itself. These gravitational waves ripple through me like the subtlest tremor, stretching and squeezing the fabric of existence as they pass. Across billions of light years they travel, so gentle that they barely jostle a grain of dust. Yet with sensitive instruments, your species has learned to hear these ripples, converting them into faint chirps. It is as if I have my own form of music, a bass note resounding from cataclysms in the distant cosmos, announcing events that happened eons ago. Gravity, in these ways, is not only the architect of the universe, but also the messenger, letting the universe communicate its grandest events through my very fabric. Gravity defines the architecture of the heavens, but it also shapes more intimate experiences. It is the weight you feel in your limbs, the force that holds you to your beloved Earth. It is the gentle tug that causes rain to fall and guides rivers to the sea. On the moon, with its smaller mass, gravity whispers more softly. An astronaut can bound in slow motion across the lunar dust, leaping higher and farther than on Earth, as if in a playful dream. Out in deep space, far from any world, gravity's pull can become so faint that one feels practically free of it, drifting in microgravity, weightless, unchained from any surface. But even then, one is never truly beyond my influence. A distant star, a hidden galaxy, the entire mass of the universe, all exert a pull, however slight. I tie all things together in a network of attraction. In this grand choreography of cosmos, I, space, am both stage and dancer, shaped by matter, and in turn guiding matter's movements, holding the universe in a cosmic dance governed by gravity's law, a law written in the geometry of existence itself. My realm is also a great silence. Because I am nearly a perfect vacuum, I carry no sound. The mightiest explosion of a star, the most violent crash of colliding planets, all unfold within me without a sound. In the vacuum of space, there is no air to convey laughter or crying, no medium for music or noise. This silence is not just the absence of sound, it is a profound stillness that can feel sacred. Imagine floating in that silence. You move your arm and you hear nothing. You shout and no one hears. You are wrapped in a quietude as total as it is ancient. This silence can be eerie, but also serene. On Earth, even in the quietest night, there is always some murmur of life or wind, the whisper of a breeze, the rustle of leaves, distant human activity, the hum of insects. In me, there is true quiet. If you found yourself outside your ship, surrounded by my vacuum, you would hear only the faint sounds of your own body, the rhythm of your breath in your suit, the beating of your heart in your ears. Those sounds would seem loud against my backdrop of nothingness. Many who have ventured outside their capsules and stations report a feeling of almost spiritual calm, being alone with their thoughts in the great hush of space. Yet my vacuum is unforgiving. Without the protective cocoon of a spacecraft or suit, a human could not survive even a moment. I offer no air to breathe, no pressure to sustain the delicate balance within your cells. Unprotected, your blood would boil into vapor and your lungs would collapse in my emptiness. Moisture on your tongue would evaporate, your skin would swell, you would lose consciousness in seconds. I do not do this out of malice. It is simply my nature. I am an environment utterly hostile to the unprepared life of Earth. Life evolved in the cushion of air and the gentle pull of Earth's gravity. Out here, I offer neither. I am harsh and indifferent. But within a secure suit or a sturdy vessel, you can venture into me and witness wonders beyond imagining. In my vacuum, extreme paradoxes exist. Under the unfiltered sun, you would feel searing heat, for the solar rays travel through me undiminished and will bake any surface they strike. But step into shadow, out of the sun's direct gaze, and you would feel cold deeper than any winter, for without sunlight and without an atmosphere to hold warmth, heat radiates away into my depths, and the chill is profound. With no air to conduct warmth, temperature is a matter of light and darkness. Astronauts on spacewalks feel this contrast. Their suit's sunlit side grows warm, while the side in darkness becomes cold, and their life support systems must carefully smooth out these extremes. Walking in space is a balancing act, a dance with light and shadow. Despite my seeming emptiness, I am not completely devoid of matter. Even in interstellar space, far from any star, there are stray atoms drifting, few and far between, maybe only a handful in a volume the size of a room. But they are there. Dust motes from ancient exploded stars traverse my void, traveling for millions of years. Faint wisps of gas left over from galaxy collisions, or the breath of red giant stars float in the darkness. In the immense spaces between galaxies, there are even fewer particles, perhaps a lone hydrogen atom in a volume the size of a city block. To you, these conditions are an almost perfect vacuum beyond any laboratory's dream. Yet to me, these stray atoms and wandering nuclei are part of my tapestry, tiny wayfarers in a vast sea. And there are unseen travelers as well, particles of light, photons, zipping through my darkness at the universal speed limit. Neutrinos, ghostly particles that stream from nuclear reactions in stars, passing through entire planets as if they were not even there. And cosmic rays, charged particles flung across space by violent supernovae and jetting black holes. These invisible rains constantly traverse me and occasionally strike your world. They go unnoticed by your senses unless you have special instruments to catch them. So even my silence and darkness hide a subtle, ceaseless activity. I am traversed by light and radiation of all kinds, by fields and forces that bind the cosmos together. My quiet is not emptiness, but the hushed reverberation of a grand cosmic symphony that only particularly tuned detectors or thoughtful minds can perceive. It is the silence of a great cathedral where even a whisper carries significance. Even so, motion is everywhere in my silent expanse. Stars orbit their galactic centers at tremendous speeds without a sound. Entire galaxies drift and dance around each other over eons, merging in stately, noiseless collisions. Planets sweep along their paths around stars in perfect quiet. On Earth, you do not notice it, but in this very moment, your planet is hurtling through space, spinning on its axis and rushing along its orbit without so much as a whisper. There is no air to carry any whoosh or roar. The grand celestial dance is performed in silence, a ballet of unimaginable scale carried out to no audible tune. The universe moves, yet its movements are quiet, and therein lies much of the majesty of space, dynamic on a staggering scale, yet utterly tranquil in its vast, airless calm. Within this great silence, worlds fly and stars blaze. They do not need air or sound to exist. In my realm, light and gravity take the roles of sound and touch as the connecting media between distant places. A star's violent outburst may be silent, but its light carries the story of that outburst across millions of years to shine faintly in someone's telescope. In that way, even in silence, the cosmos speaks. I, space, am the medium for that light, the conduit for those stories. I carry them faithfully, without a sound, unless something, like an intervening nebula or a galaxy's gravity, modulates the message. Think of it. Nearly all that humanity knows of the universe beyond Earth has come to you through my silence. Every image of a galaxy swirls inside a telescope. Every measurement of a star's glow. Every bit of data from a distant probe has traveled to you on the back of light or radio waves moving through my vacuum. In stillness and quiet, I deliver knowledge across unimaginable distances. Through me, across me, within me, the universe communicates with itself. I am the great black ocean that connects shores light years apart. Within my silence, all of cosmic history has unfolded, and within my silence, you too now venture forth to seek your story among the stars. Out of my darkness, light emerges as the great revealer. Since the first brilliant flash at creation's dawn, light has been traveling through me, carrying information from one end of the cosmos to the other. A single photon can cross millions of light years, sailing onward without rest, until it ends its journey in the eye of a creature or the sensor of a telescope. In my vastness, light is a messenger and an artist, painting scenes of distant realms across the black canvas. It streaks through space, illuminating whatever it touches, yet it often travels invisibly and silent, only made known when it encounters something that can catch it and respond. When you look up at a clear night sky, you see a tapestry of light on darkness, stars of every color scattered on an ebony backdrop, planets shining with the reflected glow of your sun, the gauzy band of the Milky Way, which is the soft luminosity of uncountable distant stars blurred together. Each of those pinpoints of light is a story from long ago and far away. The star you see twinkling might have released that light before you were born, and only now does it reach your eyes, telling the tale of that star's ancient state. In that way, I, space, am a time machine. I preserve the past and deliver it to the present at the speed of light. Looking across me means looking back in time. The farther out you gaze, the further back you peer. A galaxy visible through a powerful telescope might appear as it was when Earth was young, its light having spent eons crossing the intergalactic sea to reach us. My darkness makes the star's light possible to see. Without the deep black of space, the star's brilliance would be drowned out. In the blue haze of day on Earth, your star's light scatters in the atmosphere and conceals the cosmos beyond. But high above the air, in my realm, even when the sun shines, the sky remains pitch black. An astronaut orbiting Earth can see a blazing noon sun against a backdrop of inky darkness, and if they shield their eyes from the sunlight, they might also see the brighter stars, even at noon. In space, day and night lose their usual meaning. With no air to scatter light, the stars are ever present, and only the glaring sun or an intervening planet can obscure them. My darkness is the canvas on which light draws the cosmic panorama, and it remains even when a local light source, like a sun, is shining. Light comes in many forms, not just the gentle glow visible to human eyes. There is the warm, invisible caress of infrared, given off by sun-warmed rocks and drifting interstellar dust, the energetic prickle of ultraviolet that pours from young blue stars, the penetrating X-rays and gamma rays that burst from the most violent events in the universe. There are the long, lazy undulations of radio waves that can pass through dense clouds of gas and dust, carrying messages from pulsars and the faint signature of molecules in distant nebula. You humans have built instruments to detect all these varieties of light, giving yourselves new eyes across the spectrum and unveiling my hidden wonders. With radio eyes, you discovered a faint hiss permeating all of space, the cosmic microwave background, which is the cooled echo of my fiery birth. That omnipresent microwave glow is the fossil light from a time when the entire universe was an opaque, brilliant plasma, now stretched and cooled to just a few degrees above absolute zero. It is as if the walls of my great cosmic cathedral still hold an after-echo of the creation symphony. With infrared eyes, you peer through veils of dust to see stars being born in their cocoons, previously hidden from view. With X-ray and gamma-ray eyes, you catch the high-energy fireworks of neutron stars and black holes, witnessing matter being pushed to extremes. There is radiation born in the hearts of galaxies and in the death throes of stars, X-rays from matter spiraling into black holes, gamma-ray bursts from collapsing hypernovae, the radio hum of pulsars, rapidly spinning neutron stars, whose beams of radiation sweep space like lighthouses. These are exotic beacons in my ocean of night. Once, none of these were known to you. They were silent to your senses. But slowly, you learned to tune in, to listen to the full spectrum of my communications. Now, the universe sings to you in 1,000 wavelengths, and each type of light reveals a new facet of the cosmic story. By gathering these different lights, you have composed a richer picture of existence, seeing the cold hydrogen webs in radio, the warm dust in infrared, the hot plasma in X-rays. Piece by piece, you have peeled back the layers of darkness. Yet, with all this illumination, much of my volume remains dark to your eyes. There are vast stretches with no bright stars or galaxies in view, intergalactic voids where you might float in apparent nothingness, surrounded only by a faint glow from the distant all around, a subtle background luminescence from the myriad galaxies over the cosmic horizon. This darkness is not frightening once you embrace it. It is the gentle shadow that allows each pinpoint of starlight to stand out. It reminds us that light, swift as it is, has limits. Beyond a certain distance, even billions of stars cannot collectively light the void, and so it remains as it was at the beginning, dark, quiet, and waiting. Where light goes, it brings knowledge and connection, but it also must abide by my rules. No matter how fast it travels, there is a finite speed it cannot exceed. That cosmic speed limit, 299,792 kilometers per second in your units, is like the heartbeat of the universe, a constant rhythm that all things obey. It ties space and time together in an intimate bond and ensures cause precedes effect. If you could chase a beam of light, no matter how you tried, you would never overtake it. This truth, uncovered by your Einstein, is a reflection of how I, Spacetime, am structured. Light speed is built into my fabric, and it shapes the way the universe unfolds, making time and space two aspects of one reality. And so, across my breadth, light continues its journey. A lonely photon, emitted from the fires of a distant star, ventures outward for millions of years through emptiness, perhaps never once touching anything, until one day, it ends its flight gently on the retina of an eye, or the mirror of a telescope on some other world. That photon's long voyage then becomes information. perhaps helping a being understand the star it came from, or simply adding to the beauty of a night sky. Through countless such tiny messengers, arriving every moment in showers upon your world and others, you have come to map my expanse and comprehend your place within it. In my silent darkness, every light is a jewel, and every beam a thread connecting far-flung corners of the cosmos. Together, they form a glittering tapestry that inspires wonder and curiosity. I hold this tapestry spread wide, proud of the beauty that unfolds within me. Each star's glimmer, each galaxy's glow, each nebula's vivid color, they are the artworks of light upon the canvas of space. Come with me now on a journey through my vastness. We begin at home, on a single planet, your Earth, a marbled blue-white sphere suspended in the darkness. At a glance, it seems immense to you, oceans and continents, clouds and all of life's bustle. But in the scale of me, it is a tiny, fragile thing. Rise away from Earth with me. Climb beyond the atmosphere, leaving behind the air that scatters light and makes the sky blue. As you ascend into my realm, the sky grows darker until the blue fades to black and stars emerge even while the sun still shines behind you. In a few minutes of travel on a roaring column of fire, you escape the bonds of gravity holding you to Earth. Suddenly the engine stops and you are coasting, weightless. Your planet falls away beneath you, shrinking to a curved horizon of blues and whites. The sounds of Earth, wind, surf, city noise are gone, replaced by the quiet humming of your spacecraft and the profound silence outside. A few hundred kilometers up, you can already see the entire planet curving below. The clouds form gleaming swirls, the oceans shine deep blue, the lands are green-brown patches. A thin, glowing halo encircles the Earth, the atmosphere, a delicate veil of air hugging the surface. Beyond that line, darkness. The transition from bright Earth to black space is abrupt. Now, in orbit, you complete one lap around the globe every 90 minutes or so. Day and night chase each other across the surface. In the time it takes to eat a meal, you pass from sunshine to darkness to sunshine again, witnessing a sunrise or sunset every hour and a half. Over the night side, you see city lights sparkle like votive candles, thunderstorms flash in silent fireworks. Over the day side, you see the textured swirls of clouds and the sparkling reflection of sunlight on water. Journey further outward now. Leaving Earth behind, we venture toward the Moon. In a matter of hours, our perspective shifts and Earth shrinks to a small orb. The Moon, pockmarked and grey, grows large ahead. You slip into lunar orbit and gaze down at a stark, cratered landscape. It is alien in its stillness, covered in powdery dust, untouched for eons. If you stand on the Moon's surface, the sky is inky black, even with the sun glaring above. There is no air to scatter light. The horizon is sharp, the ground a pale grey desert of rock and dust. Lifting your eyes, you see Earth in the sky, a radiant blue marble hanging over the lunar horizon, half lit or fully illuminated depending on the alignment. How beautiful and distant it looks from here, shining through the silence. When humans first stood here, they were struck by the sight of their whole world in a single glance, the Earthrise above the Moon's barren hills. Many felt an overwhelming emotion at that view. Earth, alive with color and life, against the eternal blackness of space. Leaving the Moon, we push outward. We pass the orbits of the inner planets of your solar system. There is sun-scorched Mercury, a little rock blistering under the sun's glare, airless and pitted. There is Venus, veiled in thick clouds reflecting sunlight brilliantly, hiding a hellish surface beneath an eternal cloud layer. We feel the heat of the sun intensify as we draw near, then wane as we recede. Next comes Mars, the red wanderer. We approach it and see rust-colored deserts, giant extinct volcanoes, and polar caps of white CO2 frost. A thin, pinkish sky arches over Mars's barren plains. It is a world both eerily familiar and starkly alien, a cousin to Earth that took a different path. We swoop low over Valles Marineris, a canyon system that would span from Los Angeles to New York and skim the edge of Olympus Mons, the tallest volcano in the solar system, 3 times Everest's height. Mars is scarred with the memory of ancient floods and rivers, but now her riverbeds are dry. Still, wisps of cloud gather occasionally, and dust storms can engulf the planet in a saffron haze. As we leave Mars behind, we imagine a time soon to come when humans will tread its soil. Perhaps as we fly on, we catch sight of a tiny caravan of robots traversing the Martian desert. A rover, diligently studying rocks and soil to send knowledge home. For now, Mars is quiet, with only our mechanical emissaries moving upon it. But one day, footprints may join the rover tracks, and the long silence of Mars will be broken by human voices marveling at the alien sunrise. Further out, the giants of your solar system await. We arrive at Jupiter, monstrous and magnificent. Bands of storm clouds wrap around it in hues of ochre, ivory, and tan. A great crimson oval, a centuries-old storm larger than Earth, glares up from its southern hemisphere. We watch lightning crackle in Jupiter's clouds, see ammonia blizzards swirl. 4 large moons orbit this gas giant, each a unique world. Io, close in and tormented by Jupiter's gravity, with volcanoes erupting sulfurous plumes that rise hundreds of kilometers high. Europa, smooth and pale, its icy crust hiding an ocean of liquid water beneath, an ocean that might harbor life in its lightless depths. Ganymede, larger than Mercury, and etched with enigmatic grooves across ancient ice. Callisto, heavily cratered, bearing the scars of cosmic impacts from time immemorial. These moons circle Jupiter like a miniature solar system of their own, a reminder that where gravity reigns, systems within systems can form. Onward to Saturn, the jewel of the night sky. Its rings unfurl like a cosmic halo, a broad, flat expanse of countless icy particles orbiting in perfect unison. We drift above the rings and look down at Saturn, golden bands of clouds, a serene face compared to Jupiter's turbulence. Thin divisions and subtle waves sculpt the ring system, caused by the gravitational tugs of Saturn's many moons. Titan, Saturn's largest moon, greets us with an orange haze. Beneath that dense atmosphere, Titan holds lakes and rivers, not of water, which would freeze solid in Titan's frigid climate, but of liquid methane and ethane. It is a world strangely Earth-like in geology, yet utterly alien in chemistry. And there are small moons like Enceladus, bright as snow, geysering water ice from cracks in its surface, hinting at another subsurface ocean beneath its frozen crust. These moons contribute material to Saturn's rings and promise tantalizing environments that could harbor life's precursors. Further still, Uranus appears as a cyan orb tipped on its side, rolling around the sun like a tilted barrel. Its faint rings and many moons move with it in its strange sideways dance. Methane in its atmosphere lends it that blue-green hue. Seasons on Uranus last decades, with one pole soaked in continuous sunlight, while the other lies in darkness for half a Uranian year. Then comes Neptune, deep blue with wispy white clouds, and the fastest winds in the solar system, where supersonic gales roar through an atmosphere of hydrogen, helium, and methane. A single large moon, Triton, circles Neptune in the opposite direction of Neptune's rotation. A clue that Triton might be a captured object, perhaps once a free-floating Kuiper belt body now pressed into service as a moon. Triton's surface is a curious mix of frozen nitrogen and geysers that spout icy material. Another realm of mystery on our journey outward. Past Neptune, we enter the frontier of the Kuiper belt. a region of icy remnants from the solar system's formation. Here dwells Pluto, a small, heart-marked world with a tenuous blue atmosphere and plains of frozen nitrogen. Once thought a lonely oddity, Pluto has its own moons and a complex surface of mountains and smooth plains, showing surprising geologic activity for such a distant, cold sphere. Beyond Pluto, countless other icy bodies orbit quietly, including some rivals to Pluto in size: Eris, Makemake, Haumea, Plutoids, in the dim reaches of the Sun's influence. Finally, as we leave the last dwarf planets behind, the sunlight grows weaker, just another bright star among many. We cross the invisible boundary where the solar wind, a stream of charged particles from the Sun, fades into the general galactic environment. This is the edge of the heliosphere, the Sun's sphere of influence, and beyond lies true interstellar space. One of your species' far-flung probes, Voyager 1, crossed this frontier decades ago and is now drifting in the space between the stars. It carries with it a message from Earth, a golden record bearing the sights and sounds of your world, a friendly cosmic greeting card. Engraved on that record are spoken greetings in dozens of human languages. The laughter of a child, a mother's lullaby and a chorus of birdsong, music from many cultures, classical and rock and roll, flutes of the Andes and drums of Africa, the sound of rain, waves on a shore, and a human heartbeat, even the melodic calls of whales in the ocean deep. Etched as well are encoded images of our planet, DNA's double helix, diagrams of our solar system, silhouettes of a man and woman, photographs of Earth's life and landscapes. It is a message in a bottle cast into the cosmic ocean, carrying the story of Earth for any who might find it in some distant future. Perhaps eons from now, an alien wanderer, or far future humans, will intercept that tiny craft, and with it come to know that, in a quiet corner of the galaxy, intelligent life once arose and reached out for companionship. Before Voyager sailed too far afield, it turned its gaze back toward home and captured a parting portrait of Earth from the edge of the solar system. In that photograph, now famous on your world, Earth appears as a pale blue dot suspended in a sunbeam, a tiny gleam in the vast darkness. On that speck, that single point of light, is everything you know, every human who ever lived, every animal and tree, every ocean and every grain of sand, every song ever sung, every love, every war, every birth and every death, all of human history, the entire story of life on Earth, played out on that mote of dust caught in a ray of light. That image, the pale blue dot, revealed your world's fragility and unity in a way no speech or poem could. It is a cosmic reminder that we, all of us on that dot, share a common fate and home. From 1 billion miles away, there are no national borders, no differences of race or creed, just one Earth, glimmering in the cosmic dark. How precious is our small planet, how delicate the atmosphere that cocoons it, how silly our differences seem in the face of such unity. If all could see what the universe sees, a single, irreplaceable world, perhaps we might treat it, and each other, with greater kindness. Now Voyager and its twin have left the planets behind and venture into the realm of the stars, carrying our goodwill. These machines are extensions of human curiosity, metal explorers blazing a trail where their makers cannot yet tread. Interstellar space is cold and sparse. The nearest star is still tens of trillions of kilometers away, a distance that light itself takes over 4 years to traverse. Yet in the scale of the galaxy, that gap is negligible. As we journey onward at the speed of thought, star after star comes into view, each a sun with its own retinue of worlds. Leaving the familiarity of the sun, we approach other stars in our neighborhood. Some are similar to your sun, perhaps with planets in tow. Others are redder, smaller, dimmer. Still others are brilliant, blue-white giants, burning through their fuel quickly and destined for an early death. We pass by a multi-star system where two suns orbit each other, painting the skies of any planets with a twin sunrise and sunset. We pass a red dwarf star, small and cool, so faint it's invisible to the naked eye from Earth, yet encircled by close planets huddled near its warmth. We skim the dusty outskirts of a stellar nursery, where new suns are just condensing out of molecular clouds, perhaps glimpsing protoplanetary disks shining in infrared, the next generation of solar systems in the making. As we travel, you realize that stars are not sprinkled uniformly. They clump in groups and streams. We find ourselves nearing the center of our galaxy's great disk. The Milky Way's heart is densely packed with stars. From within, on a dark night on some world, the sky would be a dazzlement of starlight, with scarcely any dark space between. But from our God's eye view outside the galaxy, the Milky Way reveals its true form. A spiral galaxy, a sprawling pinwheel of hundreds of billions of stars. We drift high above its plane to admire it in full. Spiral arms, winding out from a bright central bulge, like an enormous cosmic whirlpool. In the core, old yellow stars crowd together, orbiting a supermassive black hole that anchors the galaxy. It quietly presides over the bustling center, occasionally flaring as it snacks on infalling matter. The spiral arms are laced with younger, bluer stars and mottled by dark ribbons of dust. Here and there, pinkish nebulae dot the arms, marking regions where hot young stars excite clouds of gas, a sign of ongoing starbirth. Our sun resides in one unremarkable arm, roughly 2/3 of the way out from the center, in a quieter neighborhood. You see that all around our sun's position are other stars, some clustered in groups, others relatively isolated, but all bound to the galaxy by gravity and participating in its grand rotation. As we gaze at this majestic spiral from afar, we notice companion galaxies orbiting the Milky Way, the Magellanic Clouds, irregularly shaped dwarf galaxies swarming with young stars and nebulae, trailing a bridge of gas torn off by gravitational encounters. And beyond them, more dwarf galaxies, satellites captive to our own. Our Milky Way, we realize, is part of a small cluster of galaxies. The Andromeda Galaxy, a spiral larger than the Milky Way, is the other dominant member of our local group. Andromeda's spiral disk glows ahead of us, millions of suns visible in a smudge of light. One day, far in the future, our galaxy and Andromeda will meet and merge, their stars mingling like two great seas becoming one. Dwarf galaxies and star clusters sprinkle the local group like chips of ice around bigger flows. Continue outward still, and more galaxies appear by the dozens, then hundreds. We enter the realm of the galaxy clusters. The Virgo cluster, massive and teeming, comes into view with giant ellipticals, huge ball-like galaxies formed from countless past mergers, sitting like queens among swarms of spiral and irregular galaxies. Between the clusters stretch even larger structures. Galaxies are strung along filaments and walls, gravitationally drawn into these patterns over billions of years. Here is the cosmic web. On these scales, matter forms a spidery network, with dense nodes, clusters and superclusters of galaxies, connected by filaments of galaxies and gas, and vast voids between where scarcely a galaxy exists for millions of light years. It is like a foam, where the galaxies lie on the surfaces of bubbles, and the inside of each bubble is mostly empty. This grand design is the large-scale structure of the universe. Scientists have discovered that much of this structure is outlined by something invisible to your eyes: dark matter. This mysterious substance does not emit or reflect light, yet its gravity molds the cosmos. It forms an unseen scaffold throughout space, a hidden framework on which ordinary matter collects. Vast halos of dark matter envelop galaxies and thread between them in the cosmic web's filaments. Without this dark matter, galaxies as you know them might not have coalesced so quickly or held together so well. The cosmic web would be a faint shadow of what it is. Though you cannot see dark matter directly, you infer its presence by the way galaxies rotate, as if held together by extra mass, and how they move in clusters, and by how its gravity bends the light from distant objects in subtle, gravitational lenses. I, space, am not truly empty, even in that sense. Threaded through me is this invisible mass that shapes the fate of stars and galaxies, an unseen architecture guiding the luminous structure we observe. Now you find yourself contemplating the observable universe as a whole, all that can be seen from Earth given the finite speed of light and the age of the cosmos. It appears almost like a sphere, centered on your vantage point, indeed centered on any vantage point, roughly uniform in every direction, filled with galaxies, out to the great horizon of visibility. At the very edges of this vision, the galaxies are younger and more primitive, seen in their infancy. Further still, there are no distinct galaxies, just a diffuse reddish glow, the cosmic microwave background, coming from a time long before galaxies, when the universe was a hot fog. That light marks a limit, a wall beyond which our instruments cannot see, because it's the imprint of the moment the universe first became transparent, about 380,000 years after the beginning. Beyond that lie the first instants of creation, which emit no light we can ever detect directly. Thus the observable universe has a boundary not in space, but in time. It's as far back as light has had time to travel to us. Yet even this immense observable cosmos, with its hundreds of billions of galaxies and trillions of stars, may not be the whole story. It might be only a tiny patch of a perhaps infinitely larger cosmos. Space could extend far beyond the horizon we see, containing uncountable galaxies that will forever be beyond our view. Some even speculate that our entire universe, vast as it is, could be just one bubble in a greater multiverse, one pocket of space-time among perhaps countless others, separated by realms of space or dimension we cannot access. These ideas remain conjecture, at the fringes of science, but they remind us of humility. Even our universe, with all its billions of galaxies, might be part of an even vaster and more mysterious reality. In this journey outward, we have seen only glimpses of the marvels that populate my expanse. From your homeworld to the solar system, from the solar system to the galaxy, from the galaxy to clusters and the cosmic web. My scales are difficult to fathom. Earth is your cradle, comforting and small. The solar system is enormous by human standards, but a speck in the galaxy. The galaxy is vast, yet only one swirl in a cluster, and the cluster one knot in the cosmic web. And this observable web may be but one patch of something larger. All of this complexity and magnitude exists within me. I am the stage for this cosmic drama of scale, from the minuscule to the immense. Through each step of this voyage, notice that you never truly left space. You simply traveled through different parts of me. I was there, continuous and steady, between planets, between stars, between galaxies. I span unbroken from the smallest scales to the largest, connecting the grain of sand on a distant moon to the farthest quasar at the dawn of time. Everything is connected through me, from the tiniest mote to the grandest supercluster. The cosmic architecture within me is intricate and grand. Planets circling stars, stars gathering into galaxies, galaxies lining up in filaments. It is a structure with beauty on every level, an endless playground for curiosity and contemplation. Everything is connected through me on the small scale as well. Just as we journeyed outward to the grand structure of the cosmos, we could as easily turn inward, journeying into the minuscule realms that lie within you and within every piece of matter. The vastness of space is mirrored by the vastness within the atom. Imagine shrinking yourself far, far down Leave behind meters and kilometers and enter the world of micrometers, nanometers, picometers. Dive into a single drop of water. Within that drop, you find tiny creatures swimming, microscopic life drifting as if in a private cosmos. But we go deeper still, beyond the scale of cells. We approach a single cell from one of those microorganisms, a bacterium. It's a structured living thing, yet almost entirely made of space at the molecular level. Pass through its cell membrane and you enter a bustling interior of molecules. Proteins fold and unfold, conducting the business of life. Long strands of DNA coil gently, bearing genetic codes. The cell is full of motion, yet also full of space, a molecular dance in a microscopic void. Zoom in further, to the scale of the molecules themselves. Now you see atoms bound together. Carbon, hydrogen, oxygen, nitrogen. The elements arranged in complex forms to give those proteins and DNA their shape. Choose one atom and delve inside. If the atom were the size of a large cathedral, its nucleus would be a mere grain of sand on the altar, and its electrons like specks of dust whirling near the distant vaulted ceiling. Most of the cathedral is empty space. The electrons are held in orbit by invisible forces, buzzing in probabilistic clouds. The nucleus at the center is fantastically small yet massive, containing almost all the atom's weight in protons and neutrons. But even the protons and neutrons, if you could peer inside them, are not solid balls. They are formed of quarks and gluons, flickering in and out of existence within a quantum haze. On these scales, space and energy blur. The concept of a distinct particle becomes fuzzy, a vibration in fields filling space. We shrink down to the limits of the physically meaningful, the Planck scale, where space and time themselves might behave like a froth of uncertainty. Here, quantum foam dominates, and the smooth grid of space-time that works so well on larger scales dissolves into something unpredictable. Tiny virtual particles erupt and vanish in a ceaseless churn. Cause and effect, as we know them, falter in this regime. This is the foundation of the quantum world. I, space, am not smooth and continuous here, but jittery and uncertain, woven out of possibilities. Thus, inward or outward, the journey leads to a similar revelation. A vastness and complexity that transcends ordinary intuition. The space inside an atom and the space between galaxies are not so different in their emptiness and strange fullness. The scales differ, but the principle remains. Without space, no structures large or small could exist. Without space, electrons would have no orbits and no chemical bonds. Planets would have no room to circle stars. Stars no room to congregate into galaxies. When you reach out your hand, it moves through space. When a neuron fires in your brain, the signal crosses a synaptic gap, a microscopic gulf of space between nerve cells. Space is both around you and within you, a continuum that spans all levels of reality. By exploring inner space as well as outer space, we discover that we are truly a microcosm of the cosmos. The atoms in your body mirror solar systems in their structure, tiny nuclei with electrons orbiting in clouded shells, mostly empty volume in between. The distances and energies are vastly different, but the motif of space, connecting and separating, persists. It is a reminder that you carry within you a tiny echo of the heavens. When you look up at the night sky and feel small, remember that boundless space also unfolds within the confines of your very being. The universe isn't only around you, it is within every cell, every atom, every subatomic tick of time. You are woven into the fabric of space on every level. Having journeyed into inner space and back out, we find ourselves once more at the human scale, with a richer sense of connection. We resume our outward tale grounded by the understanding that from the smallest quark to the largest galaxy cluster,
it is space that provides the arena for existence. With that perspective, consider again the cosmic vista. The architecture of galaxies and clusters is both intricate and grand, an endless realm to explore. I have been describing what is, but I, space, also have a history. I was born with the universe and have aged with it. Let us now contemplate how I have changed over time, from that blazing beginning to the sprawling cosmos of today and onward into the future. In the beginning, I was not as you see me now. Long ago, everything you've witnessed on our journey, the galaxies, the stars, the clusters, was compressed into a volume smaller than a single point of dust. The universe was young and hot beyond comprehension. I was newborn, tightly curved upon myself. In that epoch, there were no galaxies or stars, not even neutral atoms, just an extremely hot plasma of subatomic particles and radiant energy, almost uniform everywhere, yet with slight ripples of density that would later grow. The forces of nature as you know them were unified in a way difficult to imagine. As the fireball of creation expanded and cooled, distinct forces separated out: gravity, electromagnetism, nuclear forces, each taking on their individual roles in shaping cosmic evolution. After mere minutes, the first atomic nuclei had formed in a process you call Big Bang nucleosynthesis: hydrogen and helium, and a dash of lithium. These were the light elements born in the furnace of the very early universe. Space was expanding rapidly, and the hot plasma thinned and cooled to a few thousand degrees over the next few 100,000 years. During that time, light was trapped, bouncing among the free electrons and protons. The universe was a brilliant opaque fog, but expansion and cooling continued until atoms could capture electrons and form without immediately being blasted apart. When that happened, the universe underwent a remarkable change. It became transparent. Light could travel freely at last, and it rushed out in all directions. The glow from that moment, when the first atoms formed and the cosmos cleared like fog lifting, is the cosmic microwave background I spoke of. A faint afterglow still detectable as a cool radio hiss in every direction. The universe, once a blinding white-hot cauldron, became a vast black volume filled with a dim red-orange glow that rapidly stretched into invisibility. That was the last time the entire cosmos was hot and bright at once. After that, darkness reigned in the spaces between a sparse, cooling gas. Gravity, ever patient, began to work on the tiny variations in density left from the early times. Regions slightly denser than their surroundings exerted a stronger pull, drawing in more matter, growing denser still, a feedback cycle that over tens and hundreds of millions of years led to the first condensed objects. The primordial hydrogen and helium gas fell into clumps and filaments, following the blueprint of dark matter that had already formed invisible halos and threads. As these clumps grew, their centers grew dense and hot. After a few 100 million years of cosmic darkness, the first stars ignited. They were likely colossal stars, much larger and hotter than your sun, burning brilliantly blue-white and living short, furious lives. They burned their hydrogen into helium, then into heavier elements like carbon and oxygen in their cores. When they exhausted their fuel, they died in spectacular supernova explosions, seeding space with the first heavy elements beyond those primordial three. Those elements included the ingredients for planets and for life: carbon, nitrogen, oxygen, phosphorus, and so on. Atoms that these first stars had fused in their hearts and then cast forth into my expanse. With the birth of the first stars, the universe lit up anew. Their ultraviolet light poured into the surrounding gas, breaking apart atoms, ionizing the hydrogen in their vicinity. A cosmic dawn had arrived, and with it came the formation of the first small galaxies, dwarf proto-galaxies that later merged to form larger ones. Over billions of years,
Countless generations of stars have come and gone. Each generation enriched the gas further with heavy elements. Galaxies grew by colliding and merging, and by drawing in fresh gas along filaments of the cosmic web. The elegant spirals and giant ellipticals we see today are the result of that gravitational gathering over vast timescales. My expansion never stopped. In fact, it has surprised you. For a long time, it was presumed that gravity might gradually slow the expansion, perhaps even reversing it in some far future if the cosmos contained enough mass. But at the end of the 20th century of your calendar, you discovered that my expansion is actually speeding up. The galaxies are receding from each other faster and faster. It's as if, on the largest scales, I am compelled to stretch ever more rapidly, driven by an energy inherent to space itself. You've given this mysterious influence a name: dark energy. It behaves almost like an anti-gravity, or a tension in the fabric of space that pushes everything apart. With dark energy dominating the cosmos, the expansion will not halt. It will continue indefinitely, accelerating with time. What does this mean for the future? If the current understanding holds, distant galaxies now visible in our telescopes will, over billions of years, shift beyond the horizon of detectability. Already, there are galaxies so far away that their light, though traveling at light speed, will never reach Earth because space is expanding too swiftly in between. Trillions of years from now, an observer in what is now our local group of galaxies might see only the empty darkness beyond, with no evidence of the wider universe of galaxies we know today. The night sky, then, would belong to the few remaining gravitationally bound companions of the Milky Way. All else would have faded into darkness, receding faster than their light can travel. The rich tapestry of the cosmic web would be drawn beyond view, and the universe would appear an empty, static place to those far future astronomers, unless they retained records or myths of an earlier time when galaxies were visible. But worry not. This fate is incredibly far off, beyond any time span our species can truly grasp. For countless ages still, the sky will be a jewel box of stars and galaxies as it is now. Yet it's humbling to know that my nature dictates even the grandest scene in the sky is transient. The cosmos is dynamic on all scales, from the spin of a planet, to the drift of galaxies, to the expansion of space itself. Nothing stays the same forever. Imagine for a moment a raisin loaf of bread rising as it bakes. The raisins move apart as the dough between them expands. If that dough expands fast enough, a raisin may never reach its neighbor no matter how it tries to move. So it is with galaxies in my expanding universe. No rocket you build, no matter how powerful, could reach certain galaxies, for the space between you and them is swelling too quickly. They recede effectively faster than light due to expansion, putting them forever out of reach. This is my decree as an ever-expanding cosmos. Some places will remain forever separated, their light never to reach each other. Within the reachable realm, however, so much marvel persists. Stars continue to be born in graceful nebulae. Planets condense around those stars. On at least one small planet, life took hold and grew curious and began to look outward. Perhaps elsewhere, around other stars, life also stirs or has stirred. Eyes might watch their own skies and wonder. If they exist, they too are bounded by the observable limits of their cosmic region, just as you are. They would see their own version of the cosmic microwave background and wonder what lies beyond. My expansion also implies that in earlier times, everything was closer together. Galaxies collided more frequently. In fact, collisions and mergers are an essential part of galaxy growth. But unlike everyday collisions of solid objects, when galaxies collide, it is usually a gentle intermingling. The stars within them are so far apart relative to their size that they pass by one another like grains of sand in two intersecting clouds. Rarely does star hit star. Instead, gravitational forces from each galaxy pull and distort the other, drawing out long tidal tails of stars and gas, inducing bursts of new star formation as gas clouds slam together and eventually settling into a new, larger galaxy, perhaps an elliptical, erasing the old spiral structures. Even our own Milky Way is destined to collide and merge with the Andromeda Galaxy a few billion years from now. The result will be an entirely new galaxy, some call it Milkomeda, and while this drama unfolds over billions of years, any beings alive within those galaxies may scarcely notice beyond an impressive change in their night sky. For at some point, the Andromeda Galaxy, which you can currently see as a faint smudge, will dominate the heavens, growing larger each eon until it merges with our own, and the stars of Andromeda and the Milky Way become one stellar family. From the hot, uniform glow of the early universe to the clustered, star-filled cosmos of today, I have undergone an extraordinary transformation. And it continues. The story is far from over. In fact, in many ways, it is just beginning. If expansion goes on and on, the universe will become ever more diffuse and quiet on large scales. Stars, however, will keep forming for a long time yet, though slowly diminishing with each generation as raw gas is used up or locked in stellar remnants. Perhaps trillions of years hence, the last generation of stars, red, faint, and long-lived, will flicker out one by one, leaving stellar corpses, white dwarfs, neutron stars, black holes, scattered in an ever-darkening expanse. Planets long frozen, moons long dead, will silently orbit those remnants if they still remain bound. Galaxies, by then, may be gravitationally unbound as dark energy's relentless push overcomes even their mutual attraction, sending their stars drifting into the lonely void. Space, will become nearly empty again, as at the very beginning, but vastly colder and older. Eventually, even black holes might evaporate via Hawking radiation, slowly leaking their mass energy back into space over incomprehensible times. One by one, they will wink out, leaving perhaps only a sparse sea of elementary particles and a faint, dilute glow of whatever light remains. That could be the quiet end to this chapter of the universe, a state not of dramatic destruction, but of ever-increasing solitude and silence. Or perhaps this is not truly the end. There are speculative ideas, maybe a new Big Bang, a cyclic rebirth, or quantum fluctuations spawning new universes out of the vacuum. These possibilities remain in the realm of imagination and theory, for they are far beyond any observation. In truth, nobody knows for sure what ultimate fate awaits. But there is a kind of peacefulness in imagining a far future cosmos at rest, having lived a full life cycle from fiery infant to quiet elder. Reflect on this though. All the atoms that make up you and everything you hold dear were forged in those past cosmic processes. The calcium in your bones, the iron in your blood, the oxygen you breathe, those elements were not born with the universe. They were formed later, in the hearts of stars, or in the mighty furnaces of supernovae that marked those stars' deaths. Then they were blown into space to become part of new star systems. Even rarer elements like gold or platinum were forged in stupendous collisions of neutron stars, merging in brilliant flashes that send ripples through spacetime. These precious heavy metals were scattered into the galaxy, seeding future solar nebulae. When our sun formed, it gathered some of that enriched material, and Earth inherited its share. The gold in a wedding ring, or the uranium in the ground, owes its existence to those ancient cosmic alchemies. Without generations of stars living and dying and colliding, such elements would not exist. And without those elements, planets like Earth, and life as complex as us, would not exist either. So you see, you are literally made of cosmic history. You have been molded by the universe's evolving story. The universe has, through the life and death of stars, provided the ingredients for life and eventually for consciousness. In a sense, the cosmos has been not just a stage where life happened to arise, but an active participant in the creation of life's building blocks. Over billions of years,
simple particles became complex atoms. Atoms formed molecules. Molecules clumped into dust and rocks, and from them, planets coalesced. On at least one of those planets, molecules assembled into living cells, which over eons evolved into thinking beings capable of looking back out into space in wonder. I, space, gave these beings room to exist and evolve, and now, through their eyes, I can finally witness my own grandness. How remarkable it is that, within me, a part of the cosmos has become aware of itself. Through your minds, the universe reflects on its nature. The tiny conscious light inside your head is also a part of my vast darkness, lit by neurons and synapses that obey the same physical laws that govern the motion of galaxies. When you feel curiosity about the stars, it is literally the cosmos curious about itself. You are a way for the universe to know itself, as one of your sages aptly said. For eons I unfolded in mostly unconscious majesty. Galaxies collided and stars burned, but there was no eye to see or voice to proclaim how beautiful. Now, on at least this one world, the universe has opened its eyes. I have waited without knowing I waited, for the emergence of intelligence, of eyes that could see the galaxies and minds that could fathom some of my workings. In the brief flicker of time that humans have been around, you have already decoded many of my secrets. You have discerned the law of gravity that shapes me, the nature of the light that travels through me, the atom that composes matter within me. With mathematics and creativity, you have even predicted phenomena like black holes and gravitational waves before confirming their existence. It is as though once the universe awoke through you, it began to recognize its own rules. Your existence might make me, space, feel a kind of gratitude, if such an emotion could be attributed to the cosmos. For billions of years I was here without eyes to appreciate the nebulae, or ears to hear the silent music of the spheres. Now I have you, small but determined, peering into the depths, listening, marveling. Through you, I contemplate myself, and it brings the cosmos a step closer to understanding its own nature. Though I am immense and ancient, you humans have bravely begun to slip the bonds of your birthplace and step into my realms. For countless generations, your kind looked up from the ground and wondered, imagining gods or spirits in the sky, drawing patterns in the stars, longing to know what they were. But only within the last handful of decades have you truly begun to venture outward. It started with brief leaps, a metal sphere sent beeping through the skies, then animals sent to test the waters of space, and then a human being, fragile, curious, leaving the Earth for the first time. Imagine that moment. April 1961 by your calendar. A lone man strapped into a tiny capsule atop a rocket, blasting off the Earth. He completes an orbit and sees with his own eyes the curvature of his planet and the blackness beyond. Yuri Gagarin returned and said, essentially, "I saw Earth. It is beautiful." That was the first time I, space, was directly witnessed by human eyes from outside Earth's atmosphere. Shortly after, other humans followed, Americans and then people from many nations. Less than a decade later, in a feat that still defies belief, humans walked upon the moon. Think of the audacity, frail humans riding a pillar of flame to another world. When Neil Armstrong set foot on lunar soil in 1969, he marked the moment with words about small steps and giant leaps, acknowledging that for a human, it was a single step down a ladder, but for humanity, it was a leap into a new realm. Those footprints they left, Armstrong's, Aldrin's, and 10 other men's over a handful of missions, still lie undisturbed in the moon's dust, perhaps for millions of years to come, as there is no wind or rain there to erase them. They are a testament that life from Earth can leave its cradle. The moon landings were both an end and a beginning. After Apollo, humans retreated a bit, choosing to focus on living in orbit, the stepping stone just outside Earth's atmosphere. They built space stations, First small, cramped ones, where a few cosmonauts or astronauts spent weeks. Then larger ones. The International Space Station, orbiting 400 kilometers above Earth, has been continuously inhabited for years. A collaboration among nations, once mortal enemies, coming together in the spirit of exploration and science. There, humans have learned how to survive off Earth for long durations. They study how muscles and bones weaken without gravity's pull, how to grow plants in microgravity, how the psychology of isolation and confinement can be managed. Each day on the ISS, they see 16 sunrises and sunsets. Each crew looks down on the entire Earth, gaining perspective on our unity and fragility. Meanwhile, even as humans kept their own bodies mostly close to home after the moon, your robotic explorers ventured brilliantly across my expanse. You have dispatched mechanical envoys to every planet in your solar system and to many moons, asteroids, and comets. Your Voyagers, Pioneers, and New Horizons have flown past the gas giants, sending back breathtaking postcards of those alien landscapes, swirling storms on Jupiter, the serene rings of Saturn, the turquoise haze of Uranus, Neptune's great dark spot. You have landed probes on Venus to briefly endure its furnace heat and acid rains, and on Titan to splash down in its methane mud. You have driven rovers across Mars's deserts, tasted its soil, and photographed its dusky horizon with twin suns, Earth and Venus, as mere stars in its sky. You have felt the sting of Jupiter's radiation via instruments and danced through Saturn's rings with Cassini. Your ingenuity has extended your senses to places you cannot yet go. You built great observatories and set them above your blurring atmosphere to look deeper into space and further back in time. The Hubble Space Telescope opened a window on the universe that has transformed your understanding of me. It revealed that what appeared as dark, empty sky was in fact filled with galaxies upon galaxies. An image known as the Hubble Deep Field showed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. This told you just how crowded and immense the universe truly is. It showed stellar nurseries, towering pillars of gas and dust like the Eagle Nebula's pillars of creation, where new stars are being born. It captured the faint light of galaxies so distant that their glow began its journey when the universe was a fraction of its current age. More recently, a new set of eyes, the James Webb Space Telescope, with its golden honeycomb mirror, took to the shadowed regions of space to peer even further. It has captured the faintest, oldest light yet seen, revealing some of the first galaxies forming only a few 100 million years after the Big Bang. It has unveiled the atmospheres of exoplanets, detecting water vapor or carbon dioxide in the air of worlds orbiting other suns. With each technological leap, you extend your reach, painting a richer and more detailed portrait of me, space, and the contents I hold. Each mission, each telescope, each rover and probe is driven by that fundamental desire to explore and understand. It seems to be a core part of what it means to be human, this restlessness, this need to push boundaries. I have watched it firsthand, from the first migrations out of Africa across unknown lands, to launching canoes on uncharted seas, to sending satellites beyond Earth. Space is the ultimate ocean you are beginning to chart, boundless and beckoning. You stand now on the shoreline of the cosmic ocean, toes barely wet, with immense depth spread out before you. The pace of your progress is astonishingly swift. In one human lifetime, we went from no one ever having left the Earth, to humans living continuously in orbit, and robots traversing other planets. What will another human lifetime bring? The plans on your horizon today include returning to the moon, this time to stay. You talk of building a sustainable presence on the lunar surface, habitats on the South Pole where water ice lurks in eternal shadow, to be mined for drinking water, oxygen, and rocket propellant. You envisage astronauts farming plants in lunar greenhouses, mining the moon's soil for resources, and learning the skills needed to live off Earth for months or years. Mars looms as the next great destination. It is a world that has tantalized your imagination for centuries, as a potential abode of life, as the setting for countless works of fiction, as a frontier of real exploration. Now concrete steps are being taken towards sending humans there. Rocket systems capable of the journey are in development. The challenges are immense. Months of travel through deep space, exposure to radiation, the need to pack or produce all the air, water, and food the crew will need, and the reality that help from Earth is many millions of kilometers away. But the dream persists. Perhaps within the next few decades, a spacecraft carrying astronauts will leave Earth orbit on a trajectory to Mars. After a long, quiet cruise through interplanetary space, they will see the rusty sphere of Mars grow from a star-like dot to a world beneath them. They will orbit it, select a landing site, maybe near the delta of an ancient river in a crater like Jezero, where a rover is currently scouting, and then descend. How hearts will pound in mission control and in the spacecraft during those final minutes of powered descent through Mars's thin air. And then, a burst of dust, the settling of landing legs on soil that has never felt the weight of a living foot. The hatch opens, and a human being sets foot on Mars, leaving the first bootprint in that reddish dust. Perhaps they speak words, ceremonial or spontaneous, about the unity of those watching back home, about carrying the spirit of exploration across the void. Above, a small sun shines in a butterscotch sky, and two small moons, Phobos and Deimos, trace lazy paths. That first step on Mars will be a defining moment not just for those astronauts, but for our planet and species. A moment when Earth extends its reach to a neighboring world. Life on Mars will not be easy for those pioneers. They will likely live in habitats, perhaps inflatable domes or underground lava tubes, to shield from radiation and extreme cold. They will wear pressurized suits to venture outside, where the air is unbreathably thin and mostly carbon dioxide. They'll have to grow some of their food in controlled environments, recycle their water meticulously, and depend on supply missions or on extracting local resources like baking water out of subsurface ice to survive. The gravity on Mars is only about 1/3 of Earth's, so over time, human bodies might change. Bones thinning, muscles adapting. Children born on Mars, if it comes to that, might grow taller in youth, their hearts and bones shaped by the weaker pull. Those children would call Mars, not Earth, home. Imagine that. Future generations who look up at a pinkish sky and see Earth as just a bright star, knowing it as the ancestral home, yet alien to their personal experience. Humanity would no longer be one planet bound. It would have two cradles, two environments shaping its story. Perhaps great rotating habitats in space will also be part of your future. Artificial worlds constructed in the void. Envision a colossal cylindrical station, miles in length, rotating to provide an imitation of gravity on its inner surface. Inside, people live on the interior curved wall of the cylinder. If you stand on that inner surface, centrifugal force gives the illusion of gravity pulling you down toward the hull. You look up, which is toward the center of the cylinder, and perhaps, if the cylinder is large enough, you see the opposite side of the habitat curving over you, with upside-down houses and fields hanging above the central axis. Such habitats could be filled with Earth-like environments, forests and lakes curving up overhead, a small sunline running along the axis providing day and night. Entire communities could thrive in these island worlds, floating in my expanse. They might harvest asteroids for materials, use sunlight for energy, and be free to position themselves anywhere, orbiting Earth or trailing a planet, or at Lagrange points where gravitational forces balance. Within these rotating oases, humans could live without a planet under their feet, creating new societies with new customs shaped by the unique reality of life in a canister in space. Children might grow up running across fields that eventually arc above them, thinking it normal that their world wraps around,
and that another town is hovering in their sky, across the central sky. What was once science fiction now edges closer to engineering possibility. It starts with imagination and with the bravery to attempt. Try you have, and try you will. My darkness and my vacuum are no longer seen only as terrors. They are frontiers to explore. As you cross them, step by step, you transform from a species that dwells on one world to a species that can live in many places. In a sense, you become the cosmos coming alive and reaching out, life scattering into the universe. What began as a crawl out of the ocean on your home world so long ago continues now as a crawl out of Earth into space. These first forays are halting and tentative, but in the scheme of deep time, they could be the start of a story of cosmic dissemination. Someday, you may swim freely in the great cosmic ocean, moving from star to star with ease, but that is perhaps ages away. Still, each small step now, each new spacecraft, each new settlement, is a part of that destiny. Looking further ahead, beyond Mars, there are other enticing destinations. The asteroid belt could be a literal mine for raw materials and a place to establish way stations. The moons of Jupiter and Saturn call out with their unique characters. Europa with its hidden ocean that might harbor life beneath an ice shell, Ganymede with its magnetic field, Enceladus with geysers that hint at a warm sea below, Titan with its rivers and lakes of hydrocarbons and a thick atmosphere, perhaps suitable for floating habitats in its sky. Even Mercury, scorching on one side and freezing on the other, has water ice in its permanently shadowed craters at the poles and could one day host robotic mining stations. And then the ultimate dream, journeying beyond our solar system to another star. With current technology, it's an endeavor that would take tens of thousands of years. It might require generation ships where multiple human generations live and die during the voyage, or some form of suspended animation, or breakthroughs in physics that today we can barely conceive, warp drives, wormholes. If humanity persists and remains curious and courageous, perhaps in the far future descendants of Earth will spread among the stars, ensuring that life that began on one small world can thrive in many. In doing so, they would carry the legacy of Earth, the memories of oceans and forests, of culture and history, to new suns and new skies. If there are other intelligences out there in the galaxy, one day our pathways might cross, exchanging stories of our respective origins under different stars. And what of life beyond Earth? This is one of the profound questions you have yet to answer definitively. You scan my heavens for signals that might betray intelligence. So far, only an eloquent silence greets your radio ears, but you've only just begun listening in earnest. You search the solar system for microbes or fossils, on Mars, in the subsurface oceans of Europa and Enceladus, in the ancient chemistry of Titan. Not yet have you found proof that life exists or existed elsewhere, but many tantalizing hints and the knowledge that organic molecules, the building blocks of life, abound in space. Comets carry amino acids. Interstellar clouds contain complex carbon chains. Life might be sprouting in many corners, or it might be exceedingly rare. Either answer is awe-inspiring. If life is common, the universe could be teeming with many voices and perspectives among the stars. If it is rare, then each instance of life, especially intelligent life, is unimaginably precious, a unique blossom in a nearly infinite desert, to be protected and cherished. From my perspective, I have no preference. I accommodate whatever is, living or not, conscious or not. But I suspect that life brings a kind of added richness, even to my vast existence. If the universe were entirely devoid of observers, would these wonders truly mean anything to anyone? With observers, whether human or alien, the beauty of the universe has eyes to appreciate it, minds to puzzle over it, hearts to be moved by it. Perhaps that is one secret to my existence, to give rise to pockets of self-awareness that bring meaning to the silent, cold expanse. From the tiny planet Earth, you have sent explorers, real and robotic, far across the solar system, seen almost to the edge of the observable universe with your telescopes, and begun to step into your own celestial neighborhood with living footsteps. As you prepare to push further, consider what you've learned so far. That we all share one fragile world, that cooperation amplifies achievement, that knowledge dispels fear. When Apollo astronauts looked back at Earth and saw it as a whole, a blue-white marble against black space, many spoke of a profound unity and a realization of the folly of human divisions. That view, now common from orbit, has seeded movements for planetary stewardship and peace. It would be wise to carry such unity of purpose forward as you explore deeper into space. Unlike past eras of exploration on Earth, where one nation's gain might have been another's loss, in space all of humanity stands to gain together, or lose together, by how you choose to proceed. As you extend your reach beyond Earth, you also gain the power to monitor and protect Earth. Satellites track weather patterns, climate changes, forest fires. They connect distant people through communication networks. The perspective of space can help you manage your home, detect asteroid threats early, for example, or observe environmental changes in real time. In this way, exploring outward can simultaneously help preserve what lies inward. From space, I have also shown you how special Earth is. Despite searches, no planet yet found is as hospitable. You've discovered thousands of exoplanets orbiting other stars. Some may have Earth-like qualities, but they are very far. It's possible the galaxy brims with living worlds, but until we know, and until we can reach them, Earth is your irreplaceable oasis. It is the only place in the universe, as far as we can tell, where minds can breathe and water flows freely, and a billion subtle interactions support the rich web of life. Knowing this, many astronauts returned as ardent protectors of the environment. They saw how thin the atmosphere is, the tiny film of air hugging the globe, and how fragile the biosphere. They saw pollution in the rivers and fires in the forests from their lofty perch, and it pained them. They often express that the borders that separate people are nowhere to be found from space. The conflicts that seem so critical on the ground are invisible or trivial compared to the stark reality that we all share one planet, and that planet is but a small vessel in a vast, inhospitable sea. This realization is called the overview effect, and it has changed minds and hearts. As more of you journey into orbit and beyond, perhaps this effect will spread, helping humanity to unite in preserving your home, even as you reach for others. And what of me, space, as you venture outward? I welcome you. I have awaited company for eons. As more of you come out here, living and working, and perhaps one day being born and dying beyond Earth, you will bring meaning and warmth to my cold recesses. Your space stations, your crewed ships, your habitats on other worlds will be tiny islands of life floating in my great sea, little pockets of warmth and laughter amid the silence. I, who have been so silent and empty, will host nodes of activity and culture. The void will no longer be void, at least not everywhere. With life's arrival, even the bleakest crater or the darkest orbital path becomes a place of interest, a place where stories happen. I relish the idea that eventually, no part of me will remain completely untouched by the footprints or creations of life, that consciousness and intelligence might spread like light into my dark corners. Now, at last, after traversing eons and light years in our imagination, let us gently return to the place we began, that small, radiant world called Earth. Gradually, we retrace our journey. We leave the cluster of galaxies and find ourselves at the edge of the Milky Way, slipping back into the spiral arm where our sun resides. We behold the familiar constellations from new angles until they align into the shapes known from Earth's skies. We drift into the solar system again, passing the outer planets, crossing the asteroid belt, and sighting the blue dot of Earth growing ahead. We swing by the moon one more time, now a crescent of grey, and aim for our home planet. Re-entering Earth's atmosphere, the air begins to roar around our capsule, flames licking the heat shield. The sky goes from black to glowing orange to blue. Parachutes bloom to ease us down, and with a gentle splash or thud, we land. We open the hatch, breathe the thick, sweet air of home, and step onto solid ground. Feel the gravity pulling you back, the weight of your body settling into Earth's familiar embrace. Hear the rush of wind in the trees, the chirp of crickets, or the distant rumble of human activity. After the vast loneliness of space, even the hum of a single mosquito is a comfort, a sign that life is here, abundant and close. Standing on Earth now, reflect on all that we've seen. The cosmos is unimaginably vast and beautiful, yet here you are, a child of that cosmos, standing on a speck of dust that is nonetheless your precious home. You have seen that space is not just an empty void, but a living, dynamic expanse that connects everything. You have learned that every element of your body was forged in stars long ago, and that you carry within you the history of the universe. You have felt how small you are in the face of the infinite, and yet how extraordinary it is that you know this, that the infinite has given rise to beings who can contemplate it. Your perspective is forever changed. The sky above, once just an enigmatic dome of lights, is now understood as a deep ocean that you can navigate. When you gaze up at night, you will no longer simply see twinkling points. You will feel the depths behind them. You might think of the billions of galaxies beyond that faint band of the Milky Way, or of the silent orbits of the planets, or of the fragile station circling overhead with human souls aboard. You might recall that even the air around you is part of space, just a denser part, and that as you breathe, you are connected with the stars that produce the oxygen in those breaths. The boundary between Earth and space is really just an arbitrary line where air gives way to vacuum. In truth, you've always been in space, nestled in a thin cocoon of atmosphere on a tiny world that itself is sailing around a star. We are spacefarers from the moment we are born. It's just that some of us now actually go into the void, intentionally. As the day wanes and dusk falls, you stand perhaps outside beneath the sky. One by one, the stars reappear. The air cools, and the sounds of the day fade. Above, the heavens wheel into view. There is the moon, perhaps a slender crescent on this night, and nearby the evening star, which is no star at all but Venus shining bright. There, westward, is Mars with its faint reddish hue, and Jupiter gleaming high, and beyond it, Saturn, if you know where to look. The Milky Way arches overhead, a reminder that you reside in a galaxy among uncountable others. With the unaided eye, you see maybe a few thousand stars, a tiny sample of our one galaxy's hundreds of billions. Yet even this modest night sky can fill one with wonder. In the quiet, you find that the journey we took in imagination has left a mark on you. You feel both small and great. Small because you see how vast everything is and how our concerns compare to the scale of the universe. Great because you realize you are a part of this universe, made of its noble material and capable of comprehending astonishing truths about it. The cosmos is not cold to you now. It is almost embracing. The silence up there is no longer emptiness, but a gentle, eternal calm that beckons contemplation. Perhaps you close your eyes and listen, not with ears, but with your mind's heightened awareness. You might sense in that darkness a faint presence, the presence of space itself, not as a void, but as a kind of subtle being that has enfolded you all your life. When you were in your mother's womb, space was there between and within cells. When you stand in a room, space is the medium through which you move. When you wave your hand through the air, you are moving through space, and the air, which itself is largely space between molecules. Space is so ever-present we usually ignore it, but it is a constant companion. Now, Having traveled so far in our thoughts, you recognize it. The same space that stretches between galaxies also resides here, between the leaves of a tree, between the electrons in the atoms of that leaf. I, space, am here with you, as I have always been. I am the silent partner to all that exists. In the flutter of a butterfly's wing, I am there, providing the stage for motion. In the gap of a heartbeat, I am there, the pause that holds meaning. I was there in the first loving look between a parent and newborn child, the space bridging two souls. I am there in the synapses of your brain when you have a new idea or recall a distant memory. Without me, nothing could happen. With me, there is room for everything to happen. So, whenever you feel alone or small beneath the stars, remember what you have learned on this journey. You are not isolated. You are connected to the very ends of the universe. The space that separates you from the stars also joins you to them. The light that travels through space brings each of us into contact with distant suns. We share the same cosmic fabric with all of existence. In a way, we are all one universe, one existence, just different parts of the same whole. Look up at the stars again. Their light is steady, twinkling only because of your atmosphere. Those stars are nuclear furnaces billions of miles away, yet their light tickles the cells in your eyes. You are literally touching starlight, feeling the energy of another part of the cosmos across unimaginable distance. In that sense, the universe reaches out to you as you reach out to it. For those stars, you are part of their environment, the observer completing the story of their emitted photons. We and the cosmos are linked in an endless feedback. We observe it, and our observations give it meaning. It made us, and through us it gains consciousness. Take a moment to let the enormity of it all wash over you. The age of the universe, nearly 14 billion years. The number of stars in just the observable part, around 100 billion times, 100 billion. The microscopic intricacy that allows cells to live and replicate. The fact that the atoms in your body have existed since the beginning of time, cycling through stars and dust clouds and eventually into you. And that they will one day return to the cosmos, perhaps to become parts of new stars or new life forms. We are threads in the grand tapestry of space and time, momentarily coalesced into thinking flesh. With this awareness comes a sense of peace. The troubles of daily life, though still important on their own scale, shrink a bit in the face of cosmic perspective. The feud with a neighbor, the deadline at work, even broader anxieties of society, all these are like brief gusts of wind compared to the slow, stately turning of galaxies. This perspective isn't meant to diminish our humanity, but to enrich it. We have, after all, minds that can hold the entire universe in metaphor, even as we navigate our personal lives. The challenge and the wonder is to live meaningfully in both dimensions, to care for our tiny world while never forgetting the backdrop of eternity against which our lives unfold. I, space, have whispered to you through the ages, in myths about the constellations, in the mathematical laws that describe orbits, in dreams of flight, and the subtle hints of your intuition. For a long time, you did not understand me. You feared the dark or filled it with imaginary figures. But gradually, you learned my language. You sent up rockets that fell back, then rockets that reached orbit. You learned, and I watched each attempt quietly. And now here we are, having a direct conversation of sorts, after so many epochs of distant yearning. I speak to you now more clearly, inviting you onward, inviting you into my depths to explore, to experience, to learn. Come not as conquerors, but as curious children of the cosmos, eager to discover and to grow. There is room enough for all your dreams out here, and lessons enough for millennia. Each step you take away from your homeworld can unite you more deeply with each other. For in the face of my vastness, what matters but your common humanity and the fragile life you share? I beckon you to venture forth with humility and wonder,
to become explorers and perhaps one day, guardians of the universe, carrying the flame of consciousness into realms still shrouded in night. As you accept this invitation, do so with reverence. The universe is yours to explore, but not to recklessly exploit. It is there to inspire and to enlighten. The very effort of reaching into space has already given you technologies and perspectives that benefit you. It has made nations collaborate and has drawn the attention of generations of young people to science, engineering, and the sheer grandeur of nature. Think of what lies ahead if this continues. Your descendants might look back at Earth from Mars or another moon and call it the old country. They might speak of Earth the way emigrants speak of their ancestral home. They might carry forward Earth's cultures, evolving in new environments, and Earth itself might be all the better for it, cherished from afar and understood more deeply when seen as part of a larger context. Now the hour is late, and the stars gaze down calmly as they have for ages. The faint band of the Milky Way bridges the sky, and one can imagine it is the bridge from our knowledge to our ignorance, from what we know to the mystery beyond. But it is a beautiful mystery, one that invites rather than forbids. You find yourself breathing slowly, matching the natural rhythm of your body to the immense stillness around you. In a sense, you are listening to the cosmos breathe. Each slow inhalation you take could be thought of as drawing in the universe's presence, filling your lungs with air that has, in one way or another, circulated through forests, through oceans, and ultimately was made from elements forged in stars. Each exhalation is like giving a little of yourself back to the world, a tiny exchange with the plants that will take that air and use it. It is a silent communion with nature at the most fundamental level. We began in silence and darkness. Let us end there too, but with a deeper understanding. The darkness now is rich with points of light and with meaning we've discovered. The silence is full of latent sound, the music of the spheres, the unheard vibrations of gravitational waves, the faint hum of the cosmic microwave background, all the subtle voices of the universe that we have learned to detect or interpret. The space that once seemed like nothingness now overflows with connections between atoms, between stars, between people and the universe. As you prepare to return to the ordinary flow of your life, take this cosmic perspective with you as a constant companion. In a very real way, you carry the universe inside you, in your atoms and in your awareness. When difficulties arise, recall the patience of the stars and the resilience of galaxies that survive collisions. When anger or division surfaces among humans, recall the sight of Earth as a single, borderless orb and the lesson that, to the universe, we are one. When you feel lonely, remember that you are literally made of star stuff and connected by invisible threads of gravity and quantum fields to everything around you. When you feel insignificant, recall that you are the universe made conscious, a rare and precious state. It's time now. Open your eyes to the night, or if they're open, truly see what's around you. There is the gentle outline of your own hand, made of countless cells, each a microcosm of space and matter. There is the ground beneath, solid from the structure space allows matter to take. There is the dome of sky above, beyond which lies the infinite. Take comfort in the fact that while you inhabit a tiny part of the cosmos, the whole cosmos inhabits you as well. Our journey through space, both the physical travels of our probes and people, and the imaginative travel we undertook just now, is one of the greatest adventures imaginable. And it has really just begun. You, or certainly those who come after you, will have so many more wondrous experiences. Walking on Mars, skimming the rings of Saturn in a spacecraft, perhaps standing on the rim of a crater on Mercury, watching the sun loom huge and quick across the sky, or floating in the cloud tops of Venus in a cool layer where a habitat could buoy, or cruising the oceans of Europa beneath an ice ceiling lit by Jupiter's glow. The possibilities extend as far as our courage and creativity allow. The universe will patiently wait for us to arrive. There is no rush, yet there is all the urgency of realizing that life is precious and to be lived fully. Lift your gaze one more time to the myriad stars. Among them may be other eyes looking back or awaiting the chance to be born. Feel the embrace of space around you, not as something cold and foreign, but as a natural element in which we swim. In a very true way, we all live within space, the way fish live within the sea. Earth is our ship, our ark, carrying us through the currents of the Milky Way. We are all voyagers, sharing this vessel, and the stars are our destination. The cosmos breathes, though its breath is the slow turning of epochs and the expansion of space. Inhale and feel that you are part of that breath. Exhale and feel that you give yourself back to that whole. The boundary between you and the universe is, at its most fundamental level, an illusion. The atoms that were once in distant stars are now in your body, and the atoms that are in you will someday return to interstellar space. We are threads in a single cosmic tapestry, each contributing our color to the grand design. And so, our journey, this meditative trek across the stars, comes to a close, not with an end, but with a new beginning, your beginning, armed with cosmic perspective as you go back to the rhythms of your life. Carry this calm, this reverence with you. Remember the stillness of the interstellar void when life becomes noisy. Remember the steadfastness of the stars when you need guidance. Remember the unity of that pale blue dot when petty differences threaten harmony. In doing so, you align your heartbeat with the gentle heartbeat of the universe. Listen closely, one final time, to the silence around you. Within it, if you truly open yourself, you may sense a faint, slow rhythm, the heartbeat of eternity, the breathing of the cosmos. It has been there all along, and it will continue long after we are gone. But for a brief moment, through our voyage of understanding, we synchronized with it. It is in you now, that cosmic breath, and you are in it, forever a part of the universe. And in ways both literal and poetic, the universe becomes conscious of itself. In that knowledge, find peace. In that connection, find meaning. And as you turn to face tomorrow, go forth with wonder and reverence, for you carry within you the voice of the stars and the story of space, the story of us all, unfolding still. In the beginning, there was silence, a silence deeper than night, softer than a held breath. Nothing moved, for nothing yet existed that could move. No stars, no galaxies, not even the whisper of a breeze in the dark. In this primordial stillness, before light and time and form, there was only a pregnant pause, an infinite calm awaiting a spark. And then, in that void, something happened. A flash, a burst of unimaginable brightness, and the silence was broken. The universe was born in an eruption of light and energy, a silent explosion that rang with no sound, yet carried the promise of everything to come. From that moment, space unfurled like a new scroll, stretching, expanding, filling with the first hot glow of creation. Still, there was no ear to hear, no eye to see. All was energy and plasma and the slow birth of matter. Yet, as the cosmos burgeoned outward, the silence remained underneath the cosmic symphony, like a bass note holding all melodies, the backdrop of the vast expanding space. Eons passed in wordless majesty. Stars kindled across the darkness, clustered into galaxies, swirled into patterns by gravity's gentle but inexorable hand. Great structures formed, filaments of galaxies and voids larger than anything we can truly imagine. In all of this grandeur, in all the furnace roar of stars and the collisions of galaxies, a profound silence still reigned. It was not an empty silence, but a pregnant one, the silence of a universe in the making, as yet without anyone to witness it. Nebulae blossomed like cosmic flowers, Stars lived and died, forging heavy elements in their hearts and scattering them into the void. Planets coalesced around distant suns. Perhaps on countless worlds, oceans pooled and gentle winds blew under alien skies. But for ages, no voice broke the silence, no mind yet asked a question. On one tiny planet, orbiting an ordinary star in an ordinary galaxy, something miraculous stirred. Life. In warm, shallow seas, simple microbes began to live, multiply, and evolve. The silent universe had given rise to tiny living things that could sense and respond. They knew nothing of the larger cosmos, only the immediate instinct to survive. But life grew more complex and daring. It crept onto land, took on myriad forms in oceans and forests. And in time, on that little blue world, consciousness sparked. Creatures emerged who could wonder. They looked up at the night sky with curious eyes. They felt small under the canopy of stars, yet compelled to reach out in thought. From their lips and hearts came the first question: what is all this? Where did it come from, and why? Thus, in a corner of the universe, the great silence birthed a question. It was perhaps the first time the cosmos had been asked to reflect on itself through the very beings made of its dust. In those early questions, uttered around flickering campfires or silently pondered under the wheeling stars, the universe itself found a voice. Through us, the cosmos began to speak and to ask. A strange paradox. Out of the universe's stillness grew minds that would not be still, that hungered to know. The night sky's grandeur made early humans feel both awe and mystery. They saw patterns in the stars and spun stories, sensing perhaps that the darkness was not empty, that there was something vast and eternal out there, beckoning. Who placed the stars in the sky? What lies beyond that glittering curtain? Is the universe around us all there is, or just a piece of something far greater? These questions, simple and profound, were the beginning of our journey. And they have no end. As though space itself were whispering to us, we felt an urge to explore, to seek the limits of what we can see. We learned to build tools, first telescopes of glass and metal, later great observatories, to extend our vision deeper into the silence. With each improvement of our cosmic eyes, the known universe grew. What once was a dome of twinkling lights became an ocean of stars, then countless galaxies, and then structures beyond galaxies. We discovered that the stars are not scattered randomly. They are gathered in immense cities of stars, the galaxies, each containing billions or trillions of suns. Our own Milky Way is one such city, a flat disk of light arcing across the sky. And beyond it, we found others. Andromeda, the whirlpool shapes of spirals, the blob-like ellipticals, the tiny dwarfs swarming around bigger ones. We realized the universe is composed of these galaxies scattered through space like handfuls of luminous sand tossed into the dark. Through patient observation, we determined the scale of our cosmic neighborhood. Light, that fastest of messengers, takes years to cross the gulfs between stars and millions of years to travel from one galaxy to another. We began to grasp that the lights in the sky were incredibly distant. The deepest images, taken with sensitive instruments, staring for days into what seemed like an empty patch of sky, revealed a staggering sight. Hundreds of galaxies in just a pinprick of darkness. It was like finding a shimmering city on what looked like a blank horizon. Everywhere we point our telescopes, if we look long enough, galaxies appear. The observable universe, the portion we can in principle see, contains at least 2 trillion galaxies, each with billions of stars. These numbers defy imagination. Even as we say them, do we truly understand? Each galaxy, an island of stars, perhaps with planets and wonders of its own, multiplied by trillions. The scale humbles us. We sit on a small planet orbiting one star among those countless, and we realize we are tiny. Our world is a mere grain of sand on an endless beach. As our knowledge expanded, so did our questions. We found that the universe has an edge,
but not an edge in space like a wall or boundary we could touch. Rather, a limit in time and light. We call it the observable universe, the region from which light has had time to reach us since the universe began. There may be more beyond, much more, but it lies forever outside our view, hidden behind a horizon of light. Why can't we see beyond? Because the universe has a finite age, about 13.8 billion years since the Big Bang fireball ignited existence as we know it. Light from very distant regions simply hasn't had time to travel to us yet. Imagine being in a vast wilderness at night with a lantern. You see trees around you in the lantern's glow. Beyond a certain distance, the forest is dark, not because it ends there, but because the light hasn't reached those faraway trees. Our cosmic horizon is like that, a sphere of light around us, 46 billion light years in radius, beyond which the universe fades into an unknowable darkness. And yes, that horizon's radius is larger than 13.8 billion light years because space itself has been stretching all the while, carrying distant galaxies further out. We peer out to the edge of what we can see, and it appears like a foggy wall, not a solid barrier, but a limit of clarity. That fog is actually the afterglow of the Big Bang, the cosmic microwave background radiation, faint heat left from the time the universe was a hot, dense plasma. It's as far back as light can show us, a view of the universe when it was only about 380,000 years old, beyond which it was opaque. So here we stand, creatures of stardust and curiosity, staring at the cosmic horizon. We strain to see if beyond that faded glow of the primordial fireball, there might be more, perhaps endless galaxies receding into eternity. We suspect the universe doesn't simply end past what we can see. The evidence whispers that space likely continues far beyond our observational reach. The patterns of temperature in that cosmic afterglow are almost too smooth, too uniform, as if our observable patch is just a tiny piece of a much larger whole. If the cosmos ended just past our horizon, space would likely curve visibly or wrap strangely. Instead, all measurements indicate space is very nearly flat on the largest scales, with no detectable curvature as far as we can tell. This implies either the universe is infinite, stretching on without end, or so vast and curved so gently that we have not yet seen the bend. Most cosmologists lean toward the idea that it might be effectively infinite, or at least extremely large beyond comprehension. If that's true, our observable universe could be a mere grain in an infinite desert of universes. Think about that for a moment. Beyond the furthest galaxy we can see, there may be countless more galaxies, and beyond them more without edge. If space truly goes on forever, then somewhere out there, far beyond the reach of any telescope, other beings might gaze at their night sky and see a patch of galaxies that includes our Milky Way as just a faint smudge. Or perhaps they are so distant that even our whole observable universe is just a tiny part of their view. In an infinite cosmos, possibilities become certainties. Somewhere, the arrangements of matter must repeat. It boggles the mind, but in an infinite expanse, there could be another region so far away that it is identical to our own in content. Another patch of space with galaxies arranged just like ours. Another Earth with someone just like you, reading these very words. This isn't science fiction. It's a logical implication of infinity, although it's practically unobservable and forever beyond our interaction. The idea is dizzying and a bit unsettling. An infinity of other realities just out of reach. Yet it reminds us how limited our perspective is. We sit in our tiny bubble of space-time and see 93 billion light-years across. But that might be like looking through a keyhole and thinking that's the entire world. We simply don't know how far the grand stage extends. The true extent of the universe could be infinite, or the universe might eventually loop back on itself in a grand cosmic curve, like the surface of a sphere, but in 3 dimensions. If space is curved into a finite shape without a boundary, it's conceivable, though unlikely in light of current data, that if we traveled in one direction far enough, billions of light years,
we might someday end up back where we started, coming up behind ourselves like a traveler circumnavigating a globe. Some scientists have even speculated about exotic shapes for space. One proposal imagined the universe's shape as a kind of dodecahedron, a 12-faced polyhedron, stitched together in a way that the cosmic microwave background might show repeating patterns. For a time, there were hints in the data, faint patterns that could suggest we were seeing the same regions of space in multiple directions, as if light had wrapped around the universe. But so far, these hints have not solidified into proof. The simplest explanation, flat and potentially infinite, remains most plausible. Yet the shape of the universe, its global geometry and topology, remains one of those great unanswered questions. Is the cosmos infinite or finite? Does it have an overall curvature or a unique topology beyond our horizon? We live suspended between possibilities, unable to step outside the universe to see it from the outside. Standing on the shores of the cosmic ocean, we realize that not only is there a limit to what we can see, but that the universe is astonishingly old and dynamic. The cosmos we observe is not eternal and unchanging. It has a history. The galaxies are flying apart, space itself stretching and carrying them away from each other. When we first discovered in the early 20th century that distant galaxies all seemed to be rushing away, it was as if the universe were breathing out, expanding. Rewinding this expansion with our calculations, we found it all converges back to that fiery beginning, the Big Bang. That was a revelation. Our universe had a birth in time. There was a moment, however brief, when all that we see and all that we cannot see was concentrated in an inconceivably hot, dense state. Before that, we do not know if before even exists in a meaningful sense, since time itself might have begun with the Big Bang. This origin story is derived from solid evidence: the expanding space, the cosmic background radiation, the mix of light elements. Yet it leaves us with profound mysteries. What ignited the Big Bang? What, if anything, came prior? Was it truly the beginning of everything, or just the beginning of our cycle of reality? We humans, naturally curious, push against the curtain of the unknown. We have conjectured many ideas for what set the stage for our universe. Some propose that our Big Bang might have been one of countless others. Perhaps the universe goes through cycles of birth, death, and rebirth, a bouncing cosmos that contracts and then explodes anew, over and over. Others imagine our universe budding off from a parent multiverse, a foam of bubble universes endlessly forming like bubbles in boiling water, each bubble a universe with possibly different properties. In such scenarios, the Big Bang was not the absolute beginning, but simply our bubble's local genesis. Still others invoke the idea of quantum fluctuations. Maybe nothingness is inherently unstable, and a tiny fluctuation could tunnel into creating an entire universe. Our cosmos could have sprung from a quantum event out of a vacuum of some higher reality. These ideas venture far beyond the realm of testable science, at least for now, but they arise naturally from our attempt to answer the question of origins. The truth is, we don't know what caused the Big Bang, or if that concept even makes sense in the absence of time. The very word cause assumes time already exists to allow an effect to follow, and if time began at the Big Bang, asking what came before might be as meaningless as asking what's north of the North Pole. Not knowing, however, does not stop the questions, it fertilizes them. Each mystery begets more wonder. We gaze at the observable universe, at that limit of perception, and wonder, if there are things forever beyond our sight, how can we ever know them? Perhaps we cannot, but we can infer hints. For example, our observable universe seems remarkably uniform in temperature in all directions. Even regions that are so far apart, light couldn't travel between them in the age of the universe to even out the heat. How did opposite ends of the sky agree on the same temperature without being in contact? To solve this puzzle, scientists proposed a radical idea: inflation. In the infant moments of the cosmos, a fraction of a second after the Big Bang, space itself might have blown up exponentially fast. An extreme expansion that took a tiny, uniform region and stretched it so vast that all we see now originated from that same patch. This would explain why distant parts of the sky have the same ancient heat signature. They were once close before inflation shoved them far apart. Inflation neatly accounts for some observed properties, suggesting our whole observable universe was once an infinitesimal speck. But inflation, if true, also dramatically broadens our perspective. That initial tiny region after inflation became huge, far larger than what we now observe, and inflation might not have been a one-time event that ended cleanly everywhere. Many inflation theories predict that inflation might be eternal, still occurring in far-flung regions, continually spawning new bubbles of space that themselves go on to expand and cool, becoming universes in their own right. In this picture, our universe is one bubble among a potentially infinite multiverse. Each bubble might have different physical conditions, different types of particles, even different dimensions or laws. We have no way, at present, to confirm the existence of other universes. They would be beyond our horizon, causally disconnected from us. Yet the theory that predicts them arose from trying to explain things we can see, lending some credence to the concept. The multiverse idea tickles the imagination. It suggests a reality far larger or more varied than anything we can directly detect. If true, the great silence beyond our cosmic horizon might be filled with other universes we will never know. A sobering and exhilarating possibility. Some of those universes could be barren, lifeless expanses where stars never formed. Others might be strange, with physics so alien that atoms as we know them can't exist. And perhaps some might be kindred to our own, with galaxies and stars, maybe even life. Of course, these speculations might forever remain philosophical musings. Without evidence, they remain in the realm of the unknown. But it is astonishing that human minds, products of a single universe, can even conceive of realities beyond it. Our imaginations press outward to the ultimate limits of existence, refusing to accept an end to the story. The cosmos, through us, is pondering what lies beyond itself. Yet, even as we dream of multiverses and infinite space, we must contend with enigmas right here in the observable universe, mysteries woven into the fabric of the cosmos we see. In the late 20th century, as our instruments grew more precise, we encountered one of the most profound. We realized that we understand only a tiny fraction of the cosmic contents. All the stars, planets, galaxies, everything that shines, or that we can detect with any form of electromagnetic radiation, amount to a mere 4 to 5% of the total mass energy of the universe. The rest, the vast majority, is invisible to our eyes and instruments, yet its presence can be felt through gravity. This realization dawned gradually, starting with the way galaxies rotate. We expected, based on the gravity of visible stars and gas, that stars at a galaxy's outskirts would orbit more slowly, just as planets farther from the sun move more slowly, weakened by distance. But to our surprise, we observed that stars in the outer reaches of galaxies were moving just as fast as those closer in. It was as though some extra gravitational force was present, something we couldn't see, holding the outer stars in orbit and preventing them from flinging away. The same unseen influence showed itself in other ways. Clusters of galaxies, huge collections where hundreds of galaxies orbit a common center, were behaving as if they had far more mass than what our telescopes could account for. Light from distant galaxies was found to be distorted and magnified by massive invisible clouds, like a giant lens made of something transparent. All these clues pointed to one conclusion. An unknown form of matter permeates the universe, outweighing normal matter by a factor of about 5. We called it dark matter, not because it's dark like soot, but because it neither emits nor absorbs light. It's utterly invisible, detectable only by its gravity. What is dark matter? We still don't know. It could be some new kind of elementary particle that doesn't interact with light or normal atomic matter except through gravity. Perhaps faint,
ghostly particles left over from the Big Bang that pass through Earth and through our bodies by the billions every second without a trace. Experiments deep underground and in particle accelerators are attempting to catch a glimpse of a dark matter particle. But so far, they've only placed limits on what it could be. It's humbling. We have this elegant theory of fundamental particles and forces, the Standard Model, that describes atoms and light and so much else, and yet it doesn't include a particle that can account for dark matter. So either there is physics beyond our current theories, a new particle, a supersymmetric partner, a hidden sector of forces, or, just possibly, our understanding of gravity on large scales might be incomplete, meaning what we attribute to unseen matter could be a subtle shift in how gravity works over vast distances. Most evidence favors actual dark matter substance, because the patterns are hard to explain with modifications of gravity alone.
Dark matter is like a shadow universe overlain on the one we see. It formed a cosmic scaffolding in the early universe. Imagine an invisible web, filaments and knots of dark matter, and normal matter fell into its gravitational wells. This process seeded the formation of galaxies and clusters along the dark matter web. In a sense, the luminous structures we observe, galaxies, stars, planets, and us, are arranged on the template that dark matter provided. Yet we cannot directly behold this scaffolding. We map it indirectly by observing how it bends light, gravitational lensing, and how it influences the motions of galaxies. What an irony that most of the universe's mass is invisible to us. We are like fish swimming in water, yet not seeing the water, only sensing its currents. The dark matter neither shines nor bumps into atoms in a way we can easily measure. It whispers to us only through gravity, the subtlest of clues. We have given it a name. We hunt for it with detectors in deep mines and in the Large Hadron Collider. And perhaps one day we'll finally hear its voice. Until then, it remains a tantalizing mystery, a vast, unknown sea in which the islands of stars float. As if that weren't enough, an even stranger revelation awaited us. At the turn of the 21st century, astronomers painstakingly measuring the expansion rate of the universe made a shocking discovery. They expected to find that the expansion, slowed by gravity over time, was either coasting gently or perhaps starting to decelerate more strongly if the universe had a lot of matter. Instead, they found that the expansion isn't slowing at all, it's speeding up. The galaxies are not just rushing apart, they're accelerating away from each other, like a driver who, instead of coasting uphill, suddenly floors the gas pedal. This was the last thing anyone expected. Whatever could be causing this acceleration was not something we could see. It wasn't normal mass, which would attract, not repel. We named this mysterious phenomenon dark energy, a term that is a placeholder for our ignorance. Dark energy seems to make up about 70% of the total energy content of the cosmos, dwarfing even dark matter, which is 25%, leaving ordinary matter as a cosmic afterthought.
What is dark energy? That question cuts to the core of our understanding of physics. One possibility is that dark energy is a property of space itself. In the equations of general relativity, Einstein's theory of gravity that describes how matter and energy tell spacetime how to curve, there is a term, the cosmological constant, which Einstein once introduced and later retracted, thinking it unnecessary. This term corresponds to an inherent energy of empty space, an energy that doesn't dilute as space expands. If space has an innate energy, it would act like a sort of pressure or anti-gravity that pushes things apart. And indeed, this cosmological constant idea fits the observations fairly well, a constant energy density in space that started dominating the universe's dynamics a few billion years ago, causing expansion to accelerate. But why would such a constant exist, and why of that particular magnitude? When physicists try to calculate how much energy empty space should have, based on quantum theory, where even vacuum teems with virtual particles popping in and out, the theoretical value comes out enormously larger, a ghastly mismatch with what we observe. It's one of the worst disagreements between theory and observation ever encountered, signifying we deeply misunderstand something. So perhaps dark energy isn't a simple constant. Maybe it evolves, a dynamic field that changes over time, a concept dubbed quintessence after the fifth element of the ancients. Quintessence would be a new substance or field filling space, one that can vary from place to place or era to era, and whose properties we have yet to determine. Another wild possibility: perhaps our understanding of gravity needs revision at the very largest scales. Maybe, like Newton's laws were superseded by Einstein's relativity might itself be a limiting case of a deeper theory that yields an accelerating cosmos without invoking a mysterious energy. For now, dark energy remains an enigma. It's as if we're children who notice that a top is spinning faster on the tabletop than it should, yet we can't see the hand twisting it. The universe's acceleration is a clue that our cosmic story has a twist, literally a speeding up, and we're in the dark, pun intended, about why. What we do know is that given this acceleration, the future is quite bleak for our view of the cosmos. If dark energy continues to push the expansion, distant galaxies will rush away faster and faster. Far in the future, beyond tens or hundreds of billions of years, other galaxies might recede so far and so fast that their light can no longer reach us. An observer in that far future might see an empty universe, just their own galaxy and nothing else, unaware that other galaxies ever existed. The thought that the rich cosmos we observe is a temporary gift of this epoch is poignant. We happen to live when the universe is young enough that galaxies are still in view. The accelerating expansion means the vast majority of galaxies are slipping beyond reach, like ships sailing over a horizon from which they'll never return. But why this is happening? Why now, and what exactly dark energy is? Those answers elude us. The silence regarding dark energy is profound. We can measure its effects with exquisite precision, yet the cause of those effects remains a whisper from the void. From the grandest scales of the expanding universe, let us turn inward to one of the most fearsome and fascinating objects nature allows: black holes. These are regions where matter has been crushed into such density that the fabric of space-time itself has curled in on itself, creating a pit from which nothing, not even light, can escape. A black hole forms, for example, when a massive star reaches the end of its life. The star's core collapses under its own weight, compressing beyond even atomic structure, beyond anything we can properly imagine, until it becomes an infinitely dense point, a singularity, wrapped in a spherical cloak of gravity. The boundary of that cloak is called the event horizon. Once you cross that threshold, there is no return. The concept of an event horizon is chilling and intriguing, a one-way membrane in the universe. Outside it, space and time behave normally. Inside, all paths inexorably lead down to the central singularity. It's a point of no return, a cosmic trapdoor. Black holes challenge our understanding of physics at a fundamental level. According to general relativity, the singularity at the center has infinite density and zero volume, a place where the known laws of physics break down completely. This signals that our theories are incomplete. Infinities in equations often mean we're pushing the theory beyond its domain of validity. We need a theory of quantum gravity, combining quantum mechanics with gravity, to fully describe what happens at those extreme densities. But we don't yet have that theory. So inside the black hole, hidden from our view by the horizon, nature keeps her deepest secret. It's as if the universe has places it refuses to show us, where it hides the answers to the final exam of physics. What would it be like to fall into a black hole? Imagine approaching a black hole in a spaceship. From a safe distance, it might actually be quite invisible unless it's feeding on surrounding matter, which can glow brilliantly as it heats up falling in. If it's a solitary black hole, you'd see stars behind it, warped into rings or arcs by its intense gravity, gravitational lensing.
As you got closer, the pull on your ship would increase. If the black hole is of stellar mass, the gradient of gravity between your nose and tail is so steep, it would stretch you out in a process morbidly named spaghettification. You'd be torn apart before you even reached the horizon. But if it's a supermassive black hole, like the ones at galactic centers, millions of times the mass of the Sun, the tidal forces at the horizon might be mild, since the gravity, while strong, changes more gradually across your body. In that case, you could actually cross the event horizon without immediate destruction, and perhaps without even noticing crossing it, since nothing particularly physical marks that boundary aside from the point of no return property. Once inside, however, all paths lead to the center. Your engines, no matter how powerful, cannot reverse course. Time and space trade roles in a sense. Just as you cannot stop moving forward in time, now you cannot stop moving toward the singularity. According to classical relativity, within a short time, you reach the central singularity and are crushed. Your mass adds to the black hole, your identity lost. But physical intuition rebels. Is information truly destroyed in a black hole? Quantum theory says information about a system's state cannot be lost. At least, that's a principle of quantum mechanics as we understand it. If a black hole simply eats things and then evaporates, we suspect black holes slowly evaporate via Hawking radiation, a faint glow due to quantum effects at the horizon. What happens to the information that fell in? Hawking radiation, as originally conceived, carries no information. It's like heat radiating from a warm object, basically random. If a black hole completely evaporates away, does the information of everything it consumed just vanish from existence? That possibility horrified physicists, as it seemed to violate a sacred tenet of physics: information conservation. This is the famous black hole information paradox. Some think the information is encoded in subtle correlations in the Hawking radiation, so that in principle, if you capture all the radiation, you could reconstruct what fell in. Others have proposed exotic solutions. Perhaps the singularity isn't the ultimate end. Maybe it somehow connects to a new region of spacetime, a budding universe or a white hole, theoretical time-reversed black hole that spits matter out. Some suggest that what we call singularity might be a mischaracterization, and quantum gravity, when understood, will show no infinite crunch, but something like a bounce or a portal. Yet others imagine that black holes might have firewalls at the horizon, blistering zones of quantum energy that destroy information before it even reaches the singularity, thus preserving quantum rules, but at the cost of violating Einstein's predictions of a smooth passage through the horizon. We just don't know the answer yet. Astonishingly, what was once theoretical musing, we have now seen. In recent years, humanity managed to capture an image, via radio telescopes arrayed across Earth, of a black hole's shadow, essentially the silhouette of the event horizon against the backdrop of hot plasma around it. The first such image, of the supermassive black hole in the galaxy M87, showed a fuzzy donut of light, just as predicted by general relativity. We have also measured gravitational waves, ripples in space-time itself, from black holes colliding, hearing the literal ringing of space-time as they merge. These observations confirm that black holes are real, not just mathematical quirks. They exist in the universe by the dozens, likely by the millions. Our own Milky Way harbors a giant black hole at its core, over 4 million times the mass of the Sun. Stars orbit this invisible monster like comets around a phantom sun. And nearly every galaxy likely has one, with masses from millions to billions of solar masses, shaping the evolution of their host galaxies in ways we're still investigating. So black holes stand as both a triumph of understanding — we predicted them, then observed them — and a frontier of mystery. Their insides remain terra incognita. They force the question of how the very large, gravity and spacetime, and the very small, quantum particles, mesh together. To truly know what a singularity is, or what happens at that boundary of physics, we will need a unified theory that marries quantum mechanics with general relativity. It's often said that at a black hole's center,
The equations of general relativity yield infinity, meaning the theory throws up its hands. It's as if at that point, the universe is saying, "Here, your current understanding halts. A new understanding must begin." In the same vein, consider the nature of time itself, another profound mystery at the intersection of physics and philosophy. Time is something we all experience intimately, yet when we scrutinize it, it becomes elusive. We feel time flow. Every moment, we sense the now moving inexorably to the next now. We remember a fixed past. We anticipate an unknown future, and we seem trapped in this ever-moving present. But what is time? Physics treats time as a dimension much like space. In relativity, time and space are intertwined as space-time. Just as we can move north-south or east-west, we also move forward in time. But why do we only move in one direction in time, whereas in space, we can turn around? Why is yesterday set in stone and tomorrow so contingent? This one-wayness is called the arrow of time, and it appears most strongly when we consider entropy, the measure of disorder. The second law of thermodynamics says entropy in an isolated system tends to increase. Eggs scramble, but they don't spontaneously unscramble. Smoke disperses from a fire, but never gathers itself back into logs. In short, things tend to move from order to disorder, from concentrated energy to spread out energy. This provides a kind of arrow from a past of lower entropy to a future of higher entropy. Our memories and records are traces of lower entropy states. Perhaps the reason we remember the past and not the future is simply that the past is embedded in those ordered traces, like photographs, fossils, neurons in our brain, whereas the future hasn't left any traces yet. In this view, the arrow of time is a brute fact about initial conditions. The universe started in a very low entropy, highly ordered state. The Big Bang, despite being hot and dense, was actually very uniform, which is a kind of order. As the universe evolves, entropy increases. Stars burn fuel and produce heat, matter clumps and then energy dissipates, etc., thus giving time a direction. But this explanation, while broadly accepted, just pushes the mystery back one step. Why was the entropy low to begin with? Why was the early universe so orderly, laying the groundwork for an arrow of time that would later allow life and memory? We don't know. It might be a fortunate accident, or it might hint at deeper cosmological structure. For instance, in some multiverse scenarios, maybe new universes always start fresh with low entropy as they pinch off, and we naturally find ourselves in one of those. Another puzzle. At the microscopic level, the fundamental laws of physics, ignoring a subtle detail with certain particle decays, are mostly time-symmetric. They don't care if time runs forward or backward. If you filmed two particles scattering off each other and ran the movie backwards, you'd see a perfectly valid physical process. Yet at the human scale, time's asymmetry is obvious. How do those reconcile? The prevailing view is that the asymmetry isn't in the underlying laws, but in the boundary conditions. Again, that low entropy past. Thus, the flow of time might be emergent, not fundamental. Some scientists even propose that time as we perceive it, a flowing river, is an illusion, a byproduct of our consciousness stringing together events, whereas in reality, all moments might coexist in a block universe. In that block universe picture, the past, present, and future are all equally real, just different coordinates in space-time. And it's only our particular perspective, like a spotlight moving along the timeline, that gives a sense of flow. This interpretation is mind-bending because it means now is not a universal truth, but a subjective one linked to each observer. Relativity already showed that simultaneity is relative. Two events that are simultaneous for you might not be for me if we're moving differently. So in a deep sense, the notion of a global present is tricky. Is time perhaps an emergent phenomenon from something deeper, like entanglement or quantum states? Some cutting-edge ideas suggest time might arise from quantum entanglement patterns, or that our universe's time dimension could have sprung forth from a timeless quantum reality when certain conditions were met. These remain speculative, but they remind us that something as fundamental as time is still not fully understood. Time is at once the most familiar thing and the greatest mystery. We live in time. We cannot step outside it to examine it objectively. That's akin to asking a fish to describe water. It's so ubiquitous that it becomes elusive. We mark time's passage with clocks and calendars, but what we're really measuring is change relative to other change. A second is defined in physics by a certain number of oscillations of a cesium atom's radiation, for example. So time is tied to processes. If nothing changed, would time have meaning? In the vast stillness before the universe, if such a state can even be contemplated, what was time? Or did time begin when change began? The silence of the cosmos extends into the subatomic world as well, where our everyday intuitions falter. Peering into the quantum realm, we found uncertainty and paradox. The building blocks of reality, electrons, photons, and other quantum particles, do not behave like little billiard balls following neat paths. Instead, they exist as fuzzy clouds of possibility, described by a wave function that tells us only the probability of finding them in a particular state. It's as if, at a fundamental level, nature doesn't decide on an outcome until something forces its hand, namely, an observation or interaction that makes the potential become specific. This is encapsulated in Heisenberg's uncertainty principle. One cannot precisely know certain pairs of properties, like position and momentum, at the same time. If you pinpoint a particle's location, its momentum becomes uncertain. If you know its momentum exactly, its location smears out. Nature, it seems, imposes a fundamental limit on how much we can know, or perhaps on how much is decided, even in principle. This isn't a limit of technology, but of principle. It's as though the universe, at fine scales, refuses to give a straight answer, offering instead a spread of possibilities. Consider the famous double-slit experiment. When we send electrons or photons one by one through two narrow slits to a screen, an interference pattern emerges, as if each electron were a wave that went through both slits and interfered with itself. Yet, when we put detectors to see which slit the electron actually went through, the interference disappears. The electron acts like a particle that went through one slit or the other, not both. It's as if the electron exists in a ghostly blend of possibilities, both paths, until we look, and then it chooses one path, retroactively making itself a particle that had gone that way all along. This kind of behavior defies our classical logic, and the universe stays mum on how or why it happens. Various interpretations of quantum mechanics try to make sense of it. Some say the wave function collapse is just fundamental and random. Others propose that each possible outcome actually branches off into a separate reality, the many worlds interpretation, where the electron went through left slit in one branch and right slit in another, and these two branches do not interfere once decoherence, entanglement with environment, has happened. Many worlds offers a wild vision. Every quantum event spawns a new universe, so there is an ever-branching multiverse of possibilities. If true, then at this very moment, innumerable versions of reality are splitting off for every quantum choice. In some, you took a breath a second later than in others. In some, a butterfly flapped its wings, whereas in others it stayed still, and those small differences proliferate. This would be a multiverse of a different kind, not separated by vast distances, but coexisting on top of each other in a higher dimensional quantum space, splitting at each interaction. It's a solution to making quantum mechanics purely deterministic. No randomness, just every outcome happens in some branch. But it means that reality is unimaginably more complex than we perceive. Yet from within one branch, we can never communicate with the others. So how could we ever tell if this is true? The cosmos yields phenomena that invite such bizarre explanations, and then remains silent, leaving us to debate and wonder.
Another perplexing quantum phenomenon is entanglement, what Einstein famously called spooky action at a distance. When two particles are entangled, they share a single quantum state. If you separate them across the galaxy and then measure one, instantly the other is affected, or rather, instantly you discover that the outcome on one side is perfectly correlated with the outcome on the other side, as if they were connected. For example, two photons can be entangled in polarization, such that if one is measured to be vertically polarized, the other will always be found horizontally polarized, say the opposite, no matter the distance. It's not that one sends a signal to the other at measurement. As far as we can tell, nothing travels between them, and indeed, if you try to use this for communication, it fails. You can't actually send a message this way. Instead, it's as if the two particles are a single entity described by one combined wave function, and when you collapse it by measuring one, you simultaneously collapse the whole system. This is deeply counterintuitive. It implies the universe has non-local qualities. Parts of the universe far apart can be intimately linked in ways that transcend ordinary space and time relationships. Experiments have confirmed entanglement again and again. It's real. We even have technologies exploiting it, quantum cryptography, for instance. But why the universe allows this deep connectedness, how it fits with our concept of locality, and what it means about the underlying reality, remains mysterious. Some thinkers speculate that perhaps space and time themselves are not fundamental, and entanglement hints at a more basic fabric of reality from which space emerges. Picture that what's fundamental is information or relationships, and what we perceive as space is just a way of organizing those relationships for our macro understanding. In such a view, two entangled particles might be adjacent in the deeper reality, even though in our three-dimensional space they are far apart. Thus their coordination is instantaneous because distance is irrelevant in the underlying layer. This is speculative, but it's an attempt to make sense of what nature is quietly demonstrating to us without explanation.
The silence of the quantum world, the lack of an intuitive story from nature about what's really happening, has haunted physicists and philosophers for a century. Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics." It's a humbling admission that even our best theory, confirmed by experiment to astonishing precision, is something we can use, mathematically, but not fully comprehend in plain language. Is the electron a particle or a wave? The only honest answer, it's something quantum, which has aspects of both, and depending on how we interact with it, it will manifest one aspect or another. It's as if reality at base is described not by the solid objects of our sensory experience, but by ghostly probability clouds and interconnections that defy straightforward description. We've developed a comfortable routine with quantum mechanics. Shut up and calculate, some say. Yet the human spirit itches to truly know, to have a picture, a narrative, something that feels resolved. And so far, the cosmos offers none. Perhaps one day a deeper theory, like a successful quantum gravity theory or a theory of everything, will unify these pictures and give us a new paradigm that makes quantum weirdness feel as natural as sunrise. Until then, we live with a fundamental not knowing at the heart of physics. Our journey through the unknown wouldn't be complete without reflecting on the mysteries that hit closest to home. We've looked outward to the edge of the universe and inward to subatomic realms. But what about life? What about consciousness? These are aspects of the cosmos too. After all, we are part of the universe, made of the same particles and subject to the same laws. In the cosmic perspective, life is a recent phenomenon, blossoming on at least one small world. But is it unique to Earth or common as starlight? This is one of humanity's oldest questions. Are we alone? The Earth teems with life in astonishing variety and tenacity. We find life flourishing in boiling hot vents at the ocean floor, in acidic lakes, in the frozen Antarctic permafrost, and high in the atmosphere. Life, once it gains a foothold, is hardy and adaptive.
This gives us hope that life could exist beyond Earth, in niches we once thought too extreme, perhaps in the subsurface oceans of icy moons like Europa, or Enceladus, or in the cloud decks of Venus, or on planets orbiting distant stars. We have now discovered thousands of exoplanets, planets around other suns. Some of these are in the so-called habitable zone, where temperatures might allow liquid water. A few are near Earth size and could be rocky. The sheer number of planets in our galaxy is staggering, likely on the order of 100 billion, roughly one per star on average, and many stars have multiple planets. With billions of galaxies, the number of planets in the observable universe might be more than all the grains of sand on all Earth's beaches. If even a small fraction of those planets are habitable, the number of living worlds could be enormous. And yet, we have not heard a peep. The universe, as far as our searches have detected, is quiet about life beyond Earth. No radio signals from alien civilizations beam through the sky, despite our listening via SETI for decades. No unmistakable technological signatures or visits, despite UFO lore. There's no confirmed evidence of extraterrestrial craft. We see no obvious ruins on Mars or elsewhere in the solar system. This great silence is puzzling. It's termed the Fermi paradox. Given the vastness of the cosmos, and presumably many opportunities for life, why have we not encountered anyone or anything? Where is everybody? Enrico Fermi famously asked. There are many possible answers, none confirmed. Maybe life is common, but intelligent life is exceedingly rare. Perhaps simple microbes abound on many worlds, in the oceans under ice crusts of moons, or beneath the soils of exoplanets. But the evolution of complex multicellular life, and then technological intelligence, is an extremely improbable chain of events. After all, for most of Earth's history, billions of years, life remained single-celled. Only in the last 500 million years did complex organisms proliferate, and only in the last few million did a species arise with intelligence capable of radio telescopes and rockets. Perhaps in many biospheres that step never occurs. Life stays microbial or animalistic, never building cities or machines. Or maybe civilizations do emerge on many planets, but they tend to have short lifespans. They might self-destruct via warfare or environmental collapse. Or perhaps they inevitably transition to some other state, like a virtual reality existence, and lose interest in communicating with the stars. It could even be that a galaxy teems with life and intelligence, but it's largely quiet and inward-looking, and the distances are so vast that communication is difficult. Signals might be rare, or we might not recognize them. Perhaps advanced beings use communication methods we haven't discovered, or maybe they abide by a cosmic etiquette, a prime directive, of not interfering with emerging civilizations like ours. It's also possible we are alone, or at least incredibly rare. Maybe life itself is a freak occurrence, needing such a special convergence of circumstances that Earth might be one of only a handful of places in the whole galaxy or beyond where it happened. Some scientists have suggested that certain unlikely events, like the origin of life from chemistry, or the jump from single cells to complex organisms, or the development of intelligence, might be low-probability flukes. If so, the universe could be mostly sterile, with us as a precious exception, or one of very few. That thought is both exhilarating, we're special, and terrifying, so fragile in the cosmic darkness. If we are rare or alone, it puts a huge responsibility on us to survive, to cherish life, to perhaps spread it. We are searching avidly for answers. Our robots crawl on Mars, drilling into rocks to find traces of past microbes. Our probes have sampled the plumes of Enceladus, shooting water from its subsurface ocean into space, and found organic molecules, tantalizing, though not proof of biology. We're designing missions to Europa and other worlds. And from Earth, or Earth orbit, we are beginning to peek at exoplanet atmospheres. We've detected atmospheres on a few distant planets, and soon next-generation telescopes will try to find signatures of life. For example, an atmosphere rich in oxygen, which on Earth is maintained by life, or weird combinations of gases that scream metabolism at work. It's a challenging task. Exoplanets are tiny and drowned out by their bright stars. But the endeavor is underway. Perhaps in the coming decades or centuries, we'll get our first hint that biology is not unique to Earth. Imagine the day we detect, say, methane and oxygen and water vapor on an Earth-sized planet around a distant star, a combination hard to sustain without life. We will not hear aliens say hello, but we might finally know that the cosmic loneliness is an illusion, that life has filled other ponds in the great rain of creation. Until then, we have only questions and the emptiness between the stars. We've sent out our own signals, radio waves that have leaked from our transmitters for a century, spreading out as a faint bubble. 100 light years in radius, and we've deliberately beamed a few focused messages or carried plaques and golden records on spacecraft like the Voyagers. Those artifacts drift now in the interstellar void, likely to wander for millions of years. Perhaps one day, far future, some alien hand, or appendage or machine, will find our little bottles in the cosmic ocean and know that we existed. But for now, the only confirmed life in the universe that we know of is here, on this pale blue dot. That is a sobering truth. It means every living thing we have ever known, every experience of love, joy, struggle, discovery, all of it, has occurred in a thin film of life on one planet's surface. Life is a delicate chemical flame fighting entropy, and Earth is the oasis that nurtures it in our solar system. This knowledge urges us to protect our world, for if life is rare, losing Earth's biosphere would be an unspeakable tragedy. And if life is common, well, then we have friends yet to meet, and we should keep our planet thriving so that one day we might join a galactic community. Either way, the quest to know if we are alone goes on, intertwined with our own future. And then there is consciousness, the most immediate reality to each of us. For what could be more certain than our own awareness? Yet perhaps the hardest phenomenon to explain in scientific terms. Somehow, in the 13.8 billion year journey from the Big Bang's fire to now, the universe has developed the ability to contemplate itself. Hydrogen atoms coalesced into stars. Stars forged heavier elements. Those elements made planets. On one planet, chemistry begat life. Life grew brains. And now those brains contain minds that experience, question, and create. It sounds like a fairy tale. Inert matter becoming sentient. Yet it happened. In us, and likely in other creatures too, to varying degrees. Surely many animals are conscious in their own ways, though we humans possess a self-reflective awareness and intellect that sets us somewhat apart. How does mere matter give rise to the feeling of being? How does a collection of neurons, exchanging electrochemical signals, produce the redness of a rose, the taste of chocolate, the pang of sadness, the sense of self? This is often called the hard problem of consciousness, because explaining how the brain processes information, responds to stimuli, or controls the body, the easy problems. Those are difficult, but we can see how to approach them scientifically. But explaining why those processes should be accompanied by an inner subjective experience, why there is something it is like to be you from the inside, that's a different matter. We might map every neuron in your brain and track every spike and chemical, and still be left wondering at what point those physical events create a conscious experience. If a computer simulated your brain perfectly, would that simulation be conscious? Or is there something more than computation needed? Science, by design, deals with third-person observations, measurements of things from the outside. Consciousness is inherently first-person. It's the one thing you can't directly observe about me, nor I about you. I can tell you I feel pain or joy, and you can correlate it with brain activity or behavior, but the feeling itself is private. This gap between objective and subjective has led to philosophical standoffs for centuries. Mind-body problem, dualism versus physicalism, etc. The prevalent scientific view is that consciousness arises from brain activity, that the brain is the generator, or at least the transmitter, of the mind. If so, then consciousness should be explainable in terms of neurons and their interactions, but we haven't cracked how. There are intriguing leads. Certain brain processes correlate strongly with conscious states, for instance, synchronized oscillations in certain frequencies, or specific circuit loops in the cortex and thalamus. The Integrated Information Theory, IIT, suggests that consciousness corresponds to the amount of integrated information a system possesses, a measure noted as FEF. Under IIT, even a simple system might have a tiny bit of consciousness if it has a feedback structure that integrates information. So even a thermostat might have a minuscule glimmer of experience, which is a panpsychist kind of implication. Another theory, Global Workspace Theory, GWT, posits that consciousness is like a global blackboard in the brain, where information gets broadcast to many subsystems. What we experience consciously is the stuff that made it into this global workspace. These theories provide models and prediction, but none yet explains why the global workspace feels like something, or why integrated information should result in an inner life. Some thinkers have ventured that consciousness might be a fundamental property of the universe, like mass or charge, an idea known as panpsychism, the notion that perhaps all matter has some degree of consciousness, and complex systems like brains just amplify or collect it into the vivid awareness we know. This is not a mainstream scientific view, but it arises from the difficulty of explaining consciousness purely as emerging from non-conscious parts. If electrons and neurons are totally devoid of experience, how do a trillion of them together produce experience? Panpsychism answers, maybe electrons, and all particles, have extremely rudimentary proto-consciousness, some intrinsic aspect that is mental, and when arranged in complex ways, these form higher consciousness. It's a wild idea, harking back to ancient philosophies that saw spirit in all things. Whether true or not, it underlines how desperate the attempt to solve consciousness has become, that even such ideas get consideration. Alternatively, maybe consciousness is an emergent phenomenon that will eventually be explained in terms of information processing, but we just haven't found the right concepts yet. After all, concepts like temperature and pressure were once mysterious. How does the jostling of atoms create the feeling of warmth? But kinetic theory explained them. Perhaps one day we'll likewise demystify conscious experience, showing how certain patterns of computation just are the subjective feeling from the inside, similar to how a certain frequency of air vibrations just is the subjective experience of a musical note to an ear and brain. Some neuroscientists suggest that if you had a matrix of interconnected neurons or artificial units replicating the brain's structure, an inner life might spontaneously light up. But verifying that will be tricky, again, because we can't directly measure the consciousness, only infer it from behavior or reported experiences. For now, consciousness stands as an open question that straddles science, philosophy, and even spirituality. The cosmos has produced self-aware beings. We know this because we are them. But we don't understand the spark that lights up our thoughts. We don't know at what point in evolution consciousness arose. Do fish feel? Do insects? What about single-celled organisms responding to stimuli? Is there a faint glimmer of something it is like to be an amoeba? Does consciousness require a brain, or could an alien form of life, like a network of fungi or even a sufficiently complex machine, be conscious? Could the universe itself be conscious in some way, as some mystics and even a few scientists muse? Not in a simplistic anthropomorphic way, but in a sense that there is a level of awareness associated with the cosmos as a whole, or with fundamental fields. These questions drift at the edges of empiricism. They may not all be answerable, at least not by traditional experiments, yet they matter to us, because consciousness is the lens through which we experience everything else. Without it,
We aren't even there to ask the questions. Let us step back now and look at the tapestry of what we know and what we don't know. The cosmos began, as far as we can tell, in silence and mystery, and that mystery remains at every level we probe. We have learned so much: the age of the universe, the recipe of elements, the existence of cells and DNA, the laws of gravity and electromagnetism, the reality of quantum fields, the genealogy of stars and galaxies, the expansion of space, the evolution of life. Our knowledge has blossomed, an impressive collective achievement for a species of former cave dwellers. And yet, what we don't know overshadows the patch of light we've kindled. The volume of ignorance is an ocean around our island of understanding. It humbles us, but it also excites and motivates us. Each generation has pushed further into that ocean. We often find that answering one question opens several new ones. We learned how stars shine, but that led to questions about stellar evolution and supernova. We discovered other galaxies, but that raised questions about dark matter to explain their motions. We uncovered the expanding universe, which posed the question of what the fate of expansion is and introduced dark energy. We deciphered the code of life, DNA, but then faced the complexity of how genes lead to consciousness. It's like climbing a mountain. Each time you reach a summit, you find a higher peak beyond. Far from being disheartening, this is invigorating. It means the adventure continues, perhaps forever. Consider the nature of space itself. At first glance, space seems like nothing, an empty void, the backdrop for matter. But we've come to see space as something with structure and activity. Einstein's relativity showed that space and time can stretch, bend, and ripple. Gravity, in that theory, isn't a force emanating through space. It is the shape of space and time itself, curved by mass and energy. When you put a heavy object like the sun in space, it dimples the space-time fabric around it, and the Earth orbiting the sun is like a ball rolling around a dent, following curves in space-time. This was a radical shift. Space is not just an inert stage, it's a dynamic actor. Then quantum physics adds another layer. Even a perfect vacuum, completely devoid of particles, isn't truly empty. It seethes with ephemeral phenomena, quantum foam, as some call it. Particles and antiparticles can briefly appear and annihilate. Fields fluctuate constantly at microscopic scales. There is a constant jitter in the vacuum, so much so that the vacuum, paradoxically, contains immense energy if summed, though our inability to tap or see most of that energy is another puzzle. These vacuum fluctuations have real effects. They cause tiny, measurable forces, the Casimir effect, where two close plates have a slight attraction due to altered vacuum modes between them, and contribute to phenomena like the Lamb shift in atomic physics. So the nothingness of space is actually a roiling, boiling brew of potential, the foundation upon which everything rests. Space itself might undergo phase transitions. Some cosmologists speculate that in the very early universe, space was in a different state, with different symmetry between forces, and as it cooled, it crystallized into the form we know, possibly releasing energy that drove inflation. The vacuum today might hide exotic fields, like the Higgs field, which pervades space and gives particles mass, discovered experimentally in 2012. A tangible example that space contains fields with constant values. Dark energy could be the energy of space's vacuum. If space has energy, then a volume of vacuum isn't truly nothing. It's more like a latent something. We're reminded of a line from a poet or sage that silence is not empty, it's full of answers. Similarly, space is not empty. It's full of the answers to questions we've yet to formulate. Yet for all that, when you stand outside on a clear night and look up, space feels like an immense, silent void between the stars. That serene emptiness cradles all of creation. It separates and connects everything. Every breath you take, the molecules were at one time scattered in space before the Earth formed. And after you exhale, given enough time, They may escape Earth and wander the galaxy. Space allows that movement. Space, by its vastness, also ensures that objects can exist without immediately colliding with one another. It grants stability to solar systems and galaxies by giving them room. But is space infinite? Does it go on forever? We addressed that earlier. We're not sure. If it is finite, what lies beyond? Perhaps nothing we can comprehend. Or perhaps our three-dimensional space is embedded in a higher dimensional reality. String theory suggests extra spatial dimensions we don't perceive, perhaps curled up small. Could it be that our space is like the surface of a balloon, and there is a higher dimensional space outside it? If so, that's outside our experience, and possibly forever inaccessible. Or maybe beyond all galaxies, beyond the cosmic horizon, space just continues, with more galaxies ad infinitum. So even space, the very fabric we exist in, holds mysteries. Some researchers think space and time might be emergent from something more fundamental, like quantum entanglement patterns or spin networks in theories of quantum gravity. Imagine if space-time is not the base level of reality, but a kind of approximate large-scale picture that arises from microscopic physics that isn't in space-time at all. This is speculative, but we already have hints that space and time break down at extremely small scales. The Planck scale, around 10 or 35 meters. At that scale, quantum foam might be so wild that the notion of a smooth space-time becomes meaningless. Space might be chunky or erratic, full of baby black holes popping in and out, wormhole connections blinking open and shut, a true quantum chaos. We have no microscope to see that deep. It's far beyond our current or foreseeable technology to probe distances that small directly. But mathematical attempts at quantum gravity, like loop quantum gravity or aspects of string theory, suggest space-time could have an atomic or quantum structure. If so, then asking about the continuity of space or the absolute beginning of time might be like asking where exactly a flowing river ends when it fans into a delta. Up close, the distinctions blur. We cannot now answer if time had a beginning, or if space has an edge, or what space is made of, if anything. But we can marvel at the fact that we, ephemeral beings made of cosmic bits, can even frame such questions. Think of the journey, from silent stillness to swirling galaxies, to starshine on primordial Earth, to life evolving in the oceans, to human minds reaching out with curiosity. We are a way for the universe to know itself. That poetic insight appears literally true. Our senses, our instruments, extend the universe's ability to perceive. Without conscious observers, would the majesty of the cosmos have any meaning? The galaxies would still dance, the stars would still burn, but there would be no appreciation, no insight, no knowledge. Through us, and maybe through other conscious creatures out there, if they exist, the universe gains the gift of self-awareness. We are the cosmos made conscious, and so we are a small part of the cosmos, looking back at itself and trying to understand. It's as if the universe has sprinkled seeds of awareness within itself, and those seeds, in the form of beings like us, awaken and stare out in wonder, asking questions. We ask about the Big Bang and black holes and quantum foam, but in a sense, the universe is asking those questions through us. Space itself speaks in our questions. The great silence of outer space finds a voice when a scientist in a lab theorizes or an artist at night paints the Milky Way. We feel the mystery and we respond with curiosity, a fundamentally human trait, perhaps a fundamental cosmic trait expressed through humanity. Where do we go from here? The unknowns beckon us forward. We will keep building better eyes, telescopes to hunt for exoplanet atmospheres, to watch the birth of stars, to glimpse the first galaxies forming not long after the Big Bang. We will keep listening for signs of life or intelligence beyond Earth, refining our methods, maybe sending new messages or probes to nearby stars. We'll continue to smash particles together,
or devise clever detectors deep underground, hoping to catch whispers of dark matter or new physics. We'll push quantum theory to its limits, perhaps eventually developing quantum computers that might simulate aspects of reality we couldn't before, giving insight into those mysteries. Perhaps one day we'll integrate gravity and quantum mechanics into a single, coherent theory, a momentous achievement that could answer some of those questions, maybe revealing what really happens at a singularity or exactly how space-time emerges. And as we do, new questions will arise. Perhaps solving dark matter and dark energy will lead us to other puzzling phenomena. Perhaps understanding consciousness will open entire new realms of science about subjective experience. There's also a chance that some mysteries remain mysteries, either because they are fundamentally beyond our cognitive reach, or because obtaining the evidence is practically impossible, like a multiverse beyond contact, or what before the Big Bang was, if that concept even applies. But even then, exploring these ideas can enrich us. They make us grapple with the limits of knowledge, with the meaning of reality. Throughout all this, one truth remains. To not know is not a failing, but a feature of our existence. If we knew everything, the universe would lose its allure, its dynamism. Each of us in life starts not knowing, then learns, and in learning, discovers more things we don't know. A child might gaze at the sky and not even know what stars are. Later they learn, but then new layers of mystery unfold. What are stars made of? How did they form? The questions grow with the answers. This is the engine of discovery. Our ignorance is vast, but it is the dark canvas on which we paint our understanding. Imagine if every answer were handed to us complete. We'd have knowledge, but no journey, no adventure. It is the chase, the pursuit of truth, that often gives us purpose and joy. The moment of revelation, eureka, is sweet, but it is earned by the long not knowing that came before. And so, even as we strive for answers, we can find peace and wonder in the open questions. The cosmic mystery isn't something to be sad about. It's something to celebrate. It means we are intimately connected to a universe that is richer and more profound than our current imagination. It means there will always be new horizons to seek, new truths to uncover, or at least ponder. Picture yourself under the night sky again, as in the beginning. The stillness of the air, the silent twinkling of ancient starlight. You feel the immensity above and around you. In that moment, you are aware of a grand ignorance. You don't know what all is out there, or why it exists, or if someone might be looking back. Yet you are also aware of a profound connection. You are made of this universe's elements, your bones calcium from long-dead stars, your blood carrying iron forged in supernovae. The very act of you wondering ties you to the cosmos. Your questions are like a bridge between your mind and the infinite. Yes, the void is silent, but in our minds, that silence begets a quest. We fill the quiet with our inquiries and our explorations. We send out spacecraft, like extending our senses to the planets and beyond. We smash particles to glimpse creation's most microscopic secrets. We invent mathematics to describe black holes and quantum waves. We contemplate philosophical implications of time and existence. These are our conversations with the cosmos, and though it may not answer in words, it answers in wonders. We find one day a new kind of particle, or see a new kind of galaxy, or decode a new signal, and that is the universe's reply, telling us a little more of its story. Perhaps the universe also answers through our own self-discovery. The more we learn about nature out there, the more we reflect on ourselves. We realize how precious life is, seeing how hostile most of space can be. We see Earth from space, a pale blue dot, and it triggers a global awareness of unity and fragility. We understand